Good morning, folks. My name is Jimmy Bashar with the ISO Stakeholder Affairs Group. It's my pleasure to welcome you to the Energy Storage Enhancements meeting. Today we have an exciting discussion for you. We have a stakeholder working group that we are using to further discuss the issues identified within our issue paper that was recently published. We are grateful to have the Western Power Trading Forum here today, which Carrie Bentley will be presenting, followed by PG&E, by Alva Svoboda. And we have the California Energy Storage Alliance, or CESA, which will be presented by Sergio. And we also have a presentation from GDS Associates, presented by Paris Video Matt Smith. And then following the break, we'll have the presentation from Vistra, presented by Brad Dusek. The presentation from Phoenix Consulting, he's representing LSA and SEIA, presented by Susan Schneider. And the presentation from LS Power, presented by Renee Steichen. And then finally, SDG&E's presentation, presented by Stephen Johnson. So thank you all in advance. And I see we have a technical issue. Let me work on the slides. I'm not sure why they're showing that.
Just go ahead and reshare your screen.
Okay, thanks, Adam. Let me do that. I'm not sure what happened there. But as I'm doing that, folks, just as a reminder that this call is being recorded for stakeholder convenience, allowing those who are unable to attend to listen to recordings after the meetings. The recordings will be publicly available on the webpage for a limited time following the meeting. And of course, the recordings and any related transcriptions shall not be reprinted without the ISO permission. So let me go ahead and share this way. So it should look better, I think.
Looks good, Jimmy.
All right, thanks, Adam. So we also have, in addition to myself today from ISO, will be listeners, so thanks again in advance for everyone's time. Gabe Murtaugh, who will be leading this effort, who has been leading this effort. And I believe Gabe has some words to say before we kick off. So Gabe, take it away.
Yeah, I'd just like to echo what Jimmy said and thank everybody for joining us today. I think our goal here is to really review the items that we outlined in our issue paper, which we put out a little while ago on the ISO website, and we allowed a period for comments, and we did a stakeholder presentation on that. And the idea here is really that we get some input from stakeholders early on in the process to try to start thinking about potential solutions to the issues that we've outlined. I know some of the presentations today do focus on solutions. Some of the other presentations focus a little bit more on making sure we have the right scope for the project. And I think still others sort of focus on general operating practices for storage resources and sort of maybe some of the broader questions we may need to consider in the future as our market continues to grow in terms of the amount of storage that we're operating and how critical storage will be in the future and how it's going to interact with all of the other resources that we have on our systems. So, you know, I think the ISO certainly acknowledges that this is an important initiative, and that's why we're undertaking it right now. And we also, you know, understand and appreciate the fact that if we wanted to completely redesign the markets around storage resources, it can be an incredibly difficult, complex undertaking. I think we have, and sort of the issues that we've teed up in the issue paper have outlined things that we can do in the next year or two to make incremental improvements for how we operate storage. With that in mind, I do think it's appropriate, at least at this point in the conversation, to continue to think about, you know, broader solutions that we could have in the space for storage resources, but very quickly we're going to need to get to a point where we're proposing solutions that we're going to start moving forward with in terms of developmenting and implementing in the ISO market, and then also continue, I think, perhaps in this process, but perhaps in another process, thinking about longer-term solutions that might be workable or desirable for storage resources as well. So there's a lot going on here and a lot to discuss today, and I certainly appreciate everybody taking the time to get their presentations together and talking to the ISO about this topic. This is one of the first stakeholder initiatives where we're implementing this part of the process, but I do think it's going to be more of a routine part of the process for other stakeholder policies going forward. So do be looking for this in other initiatives that are starting soon. But we're still in a learning phase here. So I think to the extent that people do have feedback, comments, questions, concerns, please feel free to forward those to myself or to Jimmy, and we can hopefully route those through the internal process and try to make this as good of a process as we can. But I'm very excited to be getting some early hands-on feedback from the stakeholder community early in this one. So Jimmy, if we could advance the next slide, please. Oh, great. So this is just the typical representation of where we are in the stakeholder process. We're still very early on, and we haven't actually put out a straw proposal yet. So we're sort of in this pre-straw proposal phase, but we have completed an issue paper, which sort of outlines, I would say, a broad scope of topics that might be covered in this policy. We're having this meeting today to sort of think about potential solutions and where we might go in the straw proposal, and then very shortly we'll be moving into a straw proposal after this, and then we'll have our regular process where we have drafts of the straw proposal, we'll have feedback from stakeholders, stakeholder calls, and then finally a draft final proposal and then a final proposal. We are hoping to take this to the ISO Board of Governors sometime next year. I think we're targeting right now either Q2 or Q3 of next year, but I think those dates are still in flux, and I think it depends on sort of the feedback that we get from the straw proposal and how many iterations we're going to need with this process, and then implementation would obviously be sometime after the Board of Governors meeting. So we can move on to the next slide, please.
I think the next slide, Gabe, is the presentation from WWF. Yeah.
Okay. I think we may have put up online just a very quick recap of some of the topics that we included in our issue paper. I did want to just hit on that quickly. I'm going to see if I can pull up another slide to see if I can pull up that particular slide. Just if I could get 1 minute here. Okay. So we did have an issue paper that we put out. The issue paper included several topics. Some of the topics were a little bit broader, as I mentioned earlier. They were sort of, wide-ranging issues about generally how the market could work for storage resources, but some of them were a little bit more pointed. And I think just to go over at a very high level what we're thinking about there is we do want to develop some sort of a replacement tool for the minimum stated charge requirement. That was something that is a temporary measure that we put in place for this summer and for next summer. And that measure is because of reliability issues and concerns around storage resources operating on the grid. The ISO is eager to implement a replacement solution for this tool that is compensated and provides compensation for at least storage resources but potentially for other resources in the market that can sort of move energy from one time of the day to the other. Saying that, I think it's acknowledged that solutions that are broader, that apply to more than just storage resources, could be much more challenging to implement. Also, we've talked about topics specific to bid cost recovery. We talked about topics specific to compensation for storage resources that are holding state of charge. And then we sort of had sort of odds and ends of other issues related to storage resources and how they're modeled. For example, one of the things that we know about is that as storage resources tend to get fuller in terms of state of charge, their ability to charge actually diminishes. So their P-min gets lower and lower as they get closer and closer to full state of charge. And that was one of the things that we wanted to model. So with that, I did want to turn it over to our guest speakers for today and get started. I believe, as Jimmy noted, Carrie Bentley was going to kick us off with a presentation from WPTF on those topics. So, Carrie, are you on the line right now?
And Carrie, you've been promoted, and you can unmute yourself by pressing the red icon located next to your name.
I see it. Can you guys hear me now?
Great, we can,
Hello?
Carrie. Good morning.
Excellent. Good morning. Thanks so much for hosting this workshop and inviting everyone to speak. I also appreciate the flexibility on the slides, the ability to update one. That's very helpful. So hi, everyone. I'm Carrie Bentley. I'm CEO of Gridwell Consulting. I like to say we do all things California ISO. We do a lot of storage modeling at my consulting firm, and it's public that we represent a group of CCAs to contract for long-duration storage. And it's the first long-duration storage RFO and contract negotiations in the country. So we're very excited about that, and I'm getting lots of experience with long-duration storage. So I'll touch on that later. I represent the Western Power Trading Forum at the CAISO. WPTF is a nonprofit that's dedicated to competitive markets and transparency across the West. I run what's called the CAISO Committee, and that has 50 different members, and that includes load, CCAs, supply, marketers, pretty much a broad representation across the market. Next slide, please. So I saw that you had allowed everyone 30 minutes. I certainly won't take that long. My intention here is just to do a few points about maybe some existing issues in the market and talk about what is going really well for storage and where there are enhancements still needed. And then the last thing I want to talk about is the framework in which WPTF believes that the CAISO should be making decisions around storage. And that means decisions around what tools they give storage and what constraints they put in place for them. So next slide, please. So the first thing I want to talk about is long duration storage technologies. You know, storage is really a catch-all. Right now in the market, 4 hours is predominant. I know there's some 1 hour as well, and it's all lithium ion. This is rapidly changing, and this is changing because of the needs of the grid. So the CAISO in their local area studies have identified the need for longer than 4 hour storage. In places where you end up needing longer than 5 hour, 8 hour, really lithium ion sometimes is not the ideal technology type anymore. And so we're getting lots of creative and new developing technology types. And then furthermore, the CPUC and their midterm reliability procurement effort has required load serving entities to go out and procure long duration, 8 hour plus local resources. This is expected to hit the market beginning in 2027, but could come online as early as 2025, which in terms of, you know, building up a new model, if needed, it is pretty quick. You know, many of these technologies have different bidding parameters that they need, and I noticed some of the other participants will talk about this in detail as well. You know, they have lower round trip efficiencies, which I think has meaningful impacts on grid reliability. And then they also have different attributes that need to be modeled that aren't in the existing NGR model. This includes transition times, startup times, and multiple ramp rates. think one of the hardest things about this is that these very technologies are the ones who are not used to participating in CAISO processes. And I think we see that in the participants on this working group. You do see hydrogen, for example, being mentioned, but these other new technologies, which are in the market right now and participating in RFOs, I feel like are not well represented simply because of their newness, not just with their own technology, but with CAISO processes and how a market will optimize them. I think that means that if the CAISO is sincere in optimizing and wanting these long duration resources, they're going to have to do a lot more outreach than usual. And Gabe, you have done enormous amounts of outreach, I think, with the traditional stakeholders, but I think it's going to take an even bigger effort to actually get these new technologies up and running on the grid in just ways that hasn't been needed before. So just before I got into kind of the more typical storage enhancements, on behalf of WPTF, I did want to point this out because there's a lot of interest from our members in either contracting with these resource types or moving forward with them. But there is a hurdle in that, one, their understanding of the CAISO markets is limited, and two, the CAISO model itself doesn't perfectly optimize these resources. Okay, next slide, please. So then the second topic is more about what's going on with the NGR model right now. So we believe that the CAISO should really prioritize refinements and then evaluate the need for any new products or redesigns with data. And the only way we know how to truly address the real-time multi-interval optimization challenges is to kind of crack open the optimization a little bit more and start looking at the advisory price data. You know, I look at a lot of dispatches that look suboptimal for storage. I think LS Power has an actual example in their presentation they're going to walk through. And on your own, it's impossible to analyze whether these actually are optimal or not, given where the advisory prices are. Because these are not public prices, yet your storage resource is optimized based on them, it means that when you end up getting what looks like irrational awards, it could be very rational given where those advisory prices are. We won't really know, you know, what the concern around these storage resources are operationally on the grid until we see whether it's an issue with advisory prices perhaps or something else. I mean, you hear a lot of differences in opinion on this. Some people think it is the multi-interval optimization itself that doesn't work for storage. I know other people believe it's just the advisory prices deviating from the binding prices so significantly that you end up with suboptimal after the fact schedules. And again, until we could really look at this data and until the CAISO starts storing it and making it public, I think it's impossible to know how to refine the model or add products going forward because we can't even see what we have today. Oh, please go back. Not done. Thank you. Oh, no, other way. Okay. Oh, having challenges today. All right, so please go back one more slide when you have a chance, but I'll just keep speaking to that slide. Oh, thanks. No problem. All right, so then the next thing I want to talk about is what I think is actually a known and understandable and well-established refinement that needs to be needed, and that's to the regulation parameters. And then finally, I just want to say, you know, evaluating redesigns, I think it's so important to do this with analysis. And when we looked at that process, Gabe, that you put up earlier, you know, the one that everyone sees all the time, and it says issue paper, straw proposal, and it goes on. I think there's actually a gap there in the beginning, and the gap is analysis. The gap is data. So I think between or, you know, even prior to when the CAISO puts out an issue paper, they should also put out an analysis of the problems. And I think that, you know, many years ago was an intent of the CAISO, but over time we've kind of lost that, and it's paper, paper, paper. And we're not really seeing the analysis needed to demonstrate, you know, the value or need for some of these enhancements or new products. And I think as we go forward with this storage and renewable revolution, we really need to get back to analysis. And then I added here published advisory price data again, because I really do think, you know, transparency allows other people to do that analysis as well, and it relieves the lift on the CAISO. Okay, next slide. So just a quick few points on refining the real-time optimization. The CAISO already proposed an end-of-hour state of charge bidding parameter. In WPTF's eyes, this will be a game changer for storage. So if you have a game changer that hasn't been implemented yet, for us, it's really hard to think about how you want to keep changing the market. Some of the issues that are being brought up, I can't tell if they're going to be resolved or not through that end-of-hour charge bidding parameter. And I think a lot of them will. I think implementing that and then focusing on market signals really will give us a lot more information about how storage is efficiently being used in the market. And I think until you implement that and get experience with how storage shows up when needed, it's going to be really hard to propose a replacement tool. It's actually deeply concerning to me that the CAISO is talking about even a replacement tool for MSOC. Well, it was concerning that MSOC was implemented to begin with, but regardless, I think we should see how this end-of-hour state of charge bidding parameter does, because it could be that once you have this in place, plus the CAISO's new exceptional dispatch tool for storage, that's all you need, and you don't need this MSOC constraint after all. So that's just a hypothesis I have, but again, no one will really know whether storage is going to show up exactly when and where needed in real time until they get experience with the tools that are already proposed by the CAISO and already in place. Next slide, please. So one thing, though, that I think we do know is an issue is with regulation, and this is well documented. I'm just going to run through these really quickly. So the first one is infeasible day-ahead regulation awards. Basically, a storage resource can get regulation for its full capacity in every single hour. We know that that is infeasible from a state of charge perspective because there's going to be deployment of regulation in real time. But because the day-ahead model doesn't account for deployment, it doesn't consider that, there could be adjustments to state of charge over time, and therefore ends up awarding infeasible regulation schedules. This becomes even more challenging when you end up getting a resource with day-ahead regulation and energy awards, and then it becomes almost impossible for a resource to manage to both its day-ahead energy schedule and regulation awards, because from an actual state of charge standpoint, they are infeasible. Okay, next slide, please. The next regulation is with hybrid resources, and most specifically with hybrid resources that are set up because of the ITC. You could see that during the hybrid regulation up qualification, what they do is they basically pretend the resource is not a hybrid, and they look at just the battery itself and qualify it for regulation. So if you look at the picture on the left-hand side, what happens is the regulation range is solely within the battery limit. Now, once hybrids are actually moved into the market, what happens is that regulation range doesn't float on top of, the storage output. It stays static. It's a static range. So if it's 0 to 50 megawatts, let's pretend on the battery on the left, well then in real time or in the day-ahead market, it's going to be 0 to 50 megawatts as well. That means whenever the solar resource is producing up to 50 megawatts, regulation looks completely infeasible from the hybrid resource. We know that's not true. The battery's still there. It can still provide regulation, but simply the way the CAISO is defining the regulation range means that as soon as the solar starts producing, the hybrid just looks like it can produce less and less regulation. Again, this isn't, a huge market-breaking issue, but it is an inefficiency. And certainly it'll be an inefficiency as more and more hybrid resources come online. And it will lead ultimately to, higher regulation up costs because you're going to prevent this type of resource from participating in the regulation market. This is particularly a concern because co-located resources right now can't participate in the regulation market under the new rules until I think this fall. So I think we are going to see a little bit of higher regulation prices, and then if this doesn't get fixed for hybrid, I think they'll be sustained for a little longer than they should be. Okay, next slide, please. So our last point is a very common one for WPTF, and that's simply that real-time prices should reflect actual grid reliability needs. it's really important in a nodal market for prices to be rational across the day and across location. Storage is a pure arbitrage product, so when talking about doing any fixes to the market or what's going on with storage, really storage should always show up during the highest prices. And if it's not, I think that's an issue with the market. That could be an issue with the prices. It could be an issue with how storage is being modeled. But it's not like storage has any intent to game the system or show up at any other time besides when prices are highest. So if they don't do that, I think that team needs a model fix and a market fix, not a constraint on the storage. As a pure arbitrage product, there really is kind of a nice parallel between storage market participation and real-time prices. And I think that gives us an opportunity to look really closely at both our day-ahead and real-time market pricing and ask, are they rational? Are they as expected? Is price formation actually working? So I think that's one of the best things about storage is it actually highlights the market in a way that we haven't had to worry about in a little while at the CAISO. And so ultimately, because storage is almost the perfect market product, market arbitrage product, I think that is the lens in which we should view any storage enhancements going forward. And that's the end of what I have. I have a appendix in case anyone is interested in that, but I'll take any questions now if that's allowed.
Hey, Carrie.
Thanks so much, Carrie. Yep.
Thank you for the presentation. I thought that was great. I do think that there's a lot of stuff that you're sort of hitting on that we hope to identify and take on as part of this initiative. I did have a few follow-up questions, and I think we'll allow follow-up questions from other folks here from the ISO as well, and then we'll go to the chat box and we'll start to address questions from there next. So one of the things early on in your presentation, you were talking about long duration storage, and I am also interested in starting to think about the long duration problem. And one of the things that you mentioned is that our markets may not be set up to efficiently dispatch long duration today. And I was wondering if you had any thoughts on what we would need to do to efficiently dispatch long duration storage, and some of those processes that you mentioned about moving the market in that direction, and where you thought the ISO should specifically go on those issues.
Yeah, on that, I think reaching out to individual developers on these different storage technology types, especially the ones that are much further along and have already been in pilot programs, such as iron redox, compressed air, hydrogen, second life EV. When you end up digging into it, you'll see that many of them have things like transition times or startup times that are not, and those are the simplest ones, right, that are not part of the market model. When you go to the most complex ones, you know, it ends up looking a lot like almost like a combined cycle multi-stage generator plus the NGR model. And I think that's going to be the hardest part is which resources are most worth the CAISO's effort, because obviously there's a balance, right, between what you could do and who you want to integrate before there are even actual products participating in your market. But I think early outreach will be the key there.
Yeah, I'm glad to hear you say that. And I would also just mention that the ISO is talking to long duration storage developers, and we've heard a lot about some of the new projects that could be coming onto the market. Obviously, you know, some of the long duration is in our interconnection queue right now, and there hasn't, you know, there's no steel in the ground or anything like that. But I think we are aligned, and we've heard some of the same type things, that they're not going to fit into our model that we have right now that we're using for limited energy storage devices, or LESRs, in the NGR model, and they would need some extra bells and whistles, like the type of things that we see, you know, like you mentioned, like switching times and some of the combined cycle modeling type issues might be important there. So yeah, I would say the ISO is doing that. I'd also tend to agree with your earlier statement that the ISO hasn't really started any policy to start addressing some of those questions, but we'll continue to check in with that community And I think, as we get closer to some of those being online and we find out, what is the predominant technology type out there, we can start thinking about some improvements to our models to help accommodate those resources. But I do appreciate those comments. As a second question, you mentioned bids for the end of hour. I do think that is certainly part of the scope of this project. We understand that some stakeholders have been asking for that functionality since ESDR 4, at least, and perhaps even longer than that. So I think that's definitely something that we're thinking about. One difference, though, that I sort of wanted to just stick out here in this meeting was that we do understand that bids for the end of hour for storage resources could either charge a resource or potentially discharge a resource, and that could be up to the scheduling coordinator to submit that bid. The concern that the ISO has around the minimum stated charge requirement, and the reason why we have the minimum stated charge requirement in place today, is a reliability issue. And it's a reliability issue that says, if a storage resource doesn't show up, the ISO could potentially be in jeopardy of dropping load. So it's not something that I think we would necessarily want to fix with an optional bidding parameter. We'd much rather have a tool in place, either a sufficiently far look-ahead market or another tool that bases minimums, perhaps state of charge, on some sort of forward forecast, and then uses that information to make sure that our storage fleet is charged, similar to the way our day-ahead market works today, where we're seeing the loads over a full 24-hour period, and we have the opportunity to schedule storage resources specifically to charge and discharge. So that was some of my sort of comments and thoughts on the end-of-hour state of charge tool. But I do think that it could have good applications for scheduling coordinators, and it still might be something that we should very least think about implementing for this stakeholder initiative, because it could have real benefits.
So, David, just can you clarify, when I said end-of-hour state of charge bidding parameter, I didn't mean literally prices. I meant what has already been proposed in ESDR 4, the end-of-hour state of charge range, get me to 40% to 100%. Are we talking about the same thing?
I think we might be saying the same thing.
Okay. All right, good. I just wanted to make sure there was no price involved. I just think you should implement what has already been, I think approved, right, in ESDR 4.
Right.
In the draft final proposal.
You're
yeah.
Right. That functionality is coming in place in the fall.
Yep. And then on the MSOC, I think I would have a lot easier time with your argument if you provided evidence that storage resources were not showing up in real time. And you can make the similar argument about a lot of resources, including gas, that they're in the wrong configuration to meet real-time needs, for example. So, I think more data will lend credibility to that point, certainly.
Yes, and that was my next point. I know you talked a lot about data, and you often talk about data. I tend to agree, and I think spending a little bit more time and putting a little bit more rigor into some analysis might save some headaches on our end. I think you're right. We'll find out better what our real problem is, and hopefully we'll be able to put in better tools to address the actual problem rather than sort of chasing things that we think might be the problem. So I do appreciate that, and I'm happy to pass that feedback on, and I know you've been active in passing that feedback on as well. The one other thing I wanted to mention was, and that you mentioned, which I appreciate, is the regulation range for storage resources and for hybrid resources. We definitely want to tackle regulation for storage in this initiative and at least talk about it. I don't know that we're going to be able to include the hybrid resources specifically in that, in this initiative. We do have another initiative, I think, that we're planning to kick off before the end of the year called Hybrid Evolution, where we certainly would address something like that. we might be able to get it in this initiative. If not, we'd certainly address it there, but I did want to just make a note of that as well.
Thank you, Gabe. I look forward to the hybrid evolution stakeholder initiative as well.
Yeah. Yeah, should be fun. It should be fun. Do we have anybody else from the ISO who has any questions? I would also mention we do have Ben Hobbs from the Market Surveillance Committee on the phone as well, and he might be asking some questions as he's particularly interested in storage also.
Thanks, Gabe. We have about 5 minutes left. I don't see any questions in the chat. So please, folks, push #2 if you'd like to ask a question.
So, Gabe, this is Ben. Thanks for inviting me to be here today. I do have a couple of comments. I know we don't have a lot of time left, and there's a lot that no doubt the people on the call will want to ask Carrie about. So I wanted to first ask about advisory price data, and maybe this is more a question for the ISO than for Carrie. Is why not publish the advisory price data? Is the concern that the ISO doesn't want to get blamed for losses that might arise from market participants relying on advisory prices, and then when the inevitable errors occur, there's some regret. Is caveat emptor a warning that the user should be aware not enough? Is that the issue, or what? Why isn't the ISO publishing advisory price data, as Harry suggests?
Gabe, this is Rahul here. Do you mind if I take this question?
Please do, because I do not know the answer.
Okay, Ben, and for everyone, and I'm, since we don't have anyone from technology, I'm going to try to venture into this response. So from the perspective of publishing advisory prices, it's not the intent of the ISO to not publish the price because it does not materialize. I believe the main reason is the volume of data that we would have to deal with if we were requested to publish that information. And as you know that the amount of data that ISO publishes has been growing at a very fast rate in the last 5 to 10 years. Mm-hmm. And so if you were to do it for real-time dispatch, currently if we are publishing binding prices and we want to expand, the number of advisory intervals for real-time dispatch can go from 7 to 13. So at minimum, we will have to publish 7 times the more prices. Given the improvement in technology, it's definitely feasible, but that's an added burden for us to figure out. So, I think this should be part of discussion of future solutions. If that's what gives the credibility to the market, I think ISO will consider publishing those.
Okay. Thanks, Rahul. I'm definitely sympathetic to Carrie's discussion of this, and I think that publishing them, at least a subset of them, would also give folks a heads up when conditions are quickly changing and expectations are changing. I think that's useful information for the market. So thanks, Rahul, for saying that you'll be considering this. I also had a question about regulation. So, Carrie, the example that you show, shows how regulation schedules can be infeasible if a lot of regulation energy is used. And I know that 40% is not necessarily the right number. Does anybody have any can quote experience in general about how much of regulation capacity typically gets turned into energy, and what are some worst cases? Do you see all of the regulation capacity being fully used in an interval, for example, as a worst case, or what can we say about experience thus far with batteries for regulation?
I can answer that, Ben. I actually been working on this very closely with one of the battery scheduling coordinators. The worst case is it gets all deployed and in the opposite direction of prices. So in the very worst case, right, prices are going up and everyone's trying to move up, and then batteries will be deployed for regulation down almost entirely. So the worst case I can answer. I don't know about averages, though. I think that's, again, where data would be really helpful.
So if those extremes, using it all, perhaps in the opposite direction of prices, occurs sufficiently frequently, then a conservative assumption, more conservative than 40% or whatever, might be appropriate. But it's going to be a risk-benefit balancing, because if one is too conservative, then the batteries, then less battery capacity will effectively be available for scheduling for regulation day ahead, and that has its own costs. So this is where definitely, as you point out, Carrie, some data would be useful. That ends my questions for now. Operator, I guess hand it back to you and Gabe and see if there are questions in the chat.
Thanks, Ben. No questions in the chat. I don't believe we have anyone in the queue. We are just about hitting our start time for PG&E. So to the extent folks have additional questions we couldn't get to, please place in the written questions and please send through the comments tool, which we'll explain at the end for any comments. And now, do we have Alva ready for PG&E, who will be our next presenter?
I'm ready if you can hear me.
Yes, can hear you loud and clear. Thanks, Alva. Let me pull it up.
Very good. Well,
all right, I'll be listening in for slides, so go ahead, Alva. Thanks.
Okay. Thank you very much. Thank you, Jenny, and thank you, Gabe. We're grateful for the opportunity to participate in this event with the very interesting assortment of stakeholders who are presenting today. I'll just introduce myself briefly. I'm a principal analyst in the short-term electric supply department at PG&E. That's the department that acts as the PG&E scheduling coordinator. So we are the market-facing group, essentially, the CAISO market-facing group at PG&E, both on the supply and the demand side. And I'm not presenting any official positions at PG&E, but PG&E does have a stake in this kind of initiative, both on the supply and the demand side. We have a stake in seeing markets being efficient, and we attest to that every year in our least cost dispatch compliance filing with the PUC. And then we also have a stake in seeing our storage resources used efficiently. I'd point out that pump storage is a form of long duration storage, and in fact, even watershed hydro is a form of long duration storage, although not replenishable in the same way that a battery is. But so we have some experience there, and we have a stake in seeing a parity among different resources in the market. We're also very concerned that initiatives like this help in the integration of solar and in meeting the state's emissions goals. And then finally, I might speak for some of the project people in our company who have a strong wish that initiatives get implemented in an efficient and reliable way. And I think the process that's being undertaken here is a very good start towards doing a triage and a scoping that hopefully will make initiatives like this implement in an efficient way that's manageable by PG&E and other market entities, as well as by CAISO. So with that, we can just go to the actual subject of this presentation. This is a product, a straw proposal for a product that has arisen through some discussions that I've had internally at PG&E with CAISO, particularly Gabe, and then also in some previous working sessions that we've had. So I'll just go through the slides essentially, and then see what sorts of questions there are at the end. The rationale for considering a product like this is that there are clearly opportunity costs for storage resources to shift from day-ahead awards to other hours, or being prevented from shifting from day-ahead awards to other hours in the real-time markets. And the fact that they're not compensated for those opportunity costs by the minimum state of charge constraint has led to some objections to that constraint. PG&E is obviously sympathetic to CAISO's reliability objectives in implementing that constraint as a load-serving entity. But it's clear that CAISO's not currently compensating state of charge managed resources in exactly the same way they're compensating other resources that are able to freely shift their bidding. They can bid to shift from day-ahead awards to any other hours of the day. CAISO, by managing state of charge, implements some limits on dispatch that go beyond those that are present on any other market participants. So the rationale for the product is that such an SOC firming product would allow CAISO to pay resources for foregoing those shifting opportunities. In addition, it's possible that such a product, if it were detached from the specific resource that had received the award, would also allow other market participants to step in and firm dispatch energy availability. As an example, a resource that's being kept at a high state of charge for other purposes and generally isn't participating in the energy market could potentially monetize its state of charge to some extent by being willing to step in if a resource is not does shift its awards out of particular hours in the day-ahead market. So if NGR resources choose not to firm their own awards, other NGR resources could potentially step in and firm those awards. Right, next slide. So here's an attempt to get to a definition of what this product would be. First hypothesis is that in the current market timeline, SOC firming can reasonably be procured only in the day-ahead market. And that means either as part of the day-ahead market or in the way that the MSOC is being procured essentially immediately after the market results are published. I tend to have a preference for things being integrated and for ancillary service products being procured in a co-optimal way with energy, and so the proposal here would be that SOC firming would be procured in the day-ahead market. But that, of course, imposes a different requirement from what is presently the case with the MSOC. The MSOC can be derived by CAISO by simply looking at the day-ahead awards they want to protect and then imposing that requirement on those resources. Whereas a ancillary service product of this sort would have to have its need defined in advance, much more like other ancillary service products, and it would therefore have to be independent of the SOC-managed resources day-ahead market awards. In other words, it would essentially be based on a forecast of what CAISO thought it would need in available firm SOC in real time. And how that is to be forecast is not a question I'm answering here. I think you could assume that it would be based on past experience, but there are a lot of details to be managed to get at how that requirement could appropriately be defined. So the SOC firming would then impose a minimum SOC on those resources that had awards to provide that product. And that minimum SOC, because it's being derived in the day-ahead market, would be consistent with the market awards and would be published along with the market awards to the market participants, exactly the same way it is today with ancillary services. For an SOC-managed resource, receiving such an award means that a minimum state of charge logic, just exactly like what's used now, would be enforced for that resource. So obviously what that could mean is if you get an award and your state of charge is not sufficient, you may receive uneconomic charging instructions from CAISO. Of course, you may have bids as well in place that may be used, but the way that the MSOC logic works is within a certain horizon of the time of that's defined for the MSOC, you may see your state of charge ramped up if you haven't already met it. And uneconomic charging for something like this may or may not be subject to BCR. My straw proposal would be that it should not be subject to BCR because the SOC firming AS bids are being compensated, and so it's part of your risk management to decide how you're going to bid for SOC firming, given that you're not going to receive BCR for uneconomic charging, if that ends up being the case. Okay, next slide. So just to very simply put this into the day-ahead formulation, the way it would essentially show up is as an additional cost in the objective function and as an additional constraint. So the additional cost would be the sum of the prices of SOC firming in each hour times the quantity procured, and then the constraint in the IFM algorithm would be that the sum of firm SOC procured in a given hour has to be greater than or equal to the requirement. Next slide. Again, just to sort of repeat, the idea then is that in real time, SOC firming becomes a minimum state of charge constraint. It's not connected to a day-ahead award. It's a separate minimum state of charge constraint independent of that award, but its implementation would be exactly the same as the current MSOC. And you can see that from our perspective of wanting efficient implementation, this is for us kind of a reuse of code and attractive to us at PG&E for that reason. Next slide. So I think this is an interesting and promising idea. That's why we decided to present. But I've had some discussions, and also just certain concerns are apparent in doing this. I think there are concerns that would need to be addressed in any stakeholder process that would arrive at such a product. One that has been brought up has been that it's not at all inconceivable that non-SOC managed resources could provide SOC firming. The issue with non-SOC managed resources is that there is no way within the market algorithms to guarantee that the firming is there. So the issue then would be, for such resources, how would their awards be ensured in the real-time market processes? If you see this AS as basically a reliability product, then it is not necessarily reasonable to assume that market signals alone will ensure that a resource would be providing that product. And obviously, you have to have, at a minimum, you have to have some form of performance monitoring, no pay, but perhaps even you have to think about how you could enforce in the market the ability to provide that firming. Another issue that was brought up by a gentleman at SCE was that there's a relationship between this product and other similar products being used in real time by CAISO to guarantee flexibility. And I don't see it as equivalent as long as the product applies only to SOC managed resources. But I do agree that as soon as you say, well, we're going to extend the ability to provide this product to non-SOC managed resources, you're going to see an overlap between the capacity that is being kept unloaded for SOC firming and the capacity that is being kept unloaded for flexible ramping. My straw proposal, if we wanted to get something like this done in a couple of years, would just be to limit SOC firming to SOC managed resources to avoid this issue at this point. But I think if again, it ties into that issue of how we would appropriately compensate and also sanction non-SOC resources that were providing such a product. Another question is, outages happen, batteries become unavailable. should CAISO be enabled to procure SOC firming from other batteries prior to real-time? My answer would be yes, and straw proposal would be the only way to do that in the real-time markets is using exceptional dispatch. It's not something that can really be procured in the real-time market timeline because sometimes these SOC firming requirements extend over multiple hours prior to the binding hour. And then another question would be, should for SOC managed resources, should SOC firming be included as part of its RA must offer? And should that be for all hours or only some? And should its SOC firming bid be at zero, or should it be allowed, like other resources, to bid some opportunity cost-based bid and potentially clear economically against other resources? I have no answer to that, but I think it certainly has to be answered in the process of defining this product. Next slide. So the last thing I wanted to mention is I was resistant to the MSOC, and I still have some qualms about how it's been implemented at this point because there's the MSOC requirement currently is being defined based on physical limits rather than on the upper charge limit and the lower charge limit of the storage operator's bids. And so it tends to lead to results that are, in my mind, are not that meaningful right now. But I think the implementation has led me to think about this product as something that has a lot of potential for addressing some of the issues that have been brought up in other areas of this same initiative. For one thing, an SOC firming product allows CAISO to put a forward view into real-time markets with limited horizons, or even day-ahead markets with limited horizons. So essentially, by defining a requirement, it's possible to guarantee an ability to use storage usefully in a future period that isn't represented in the market. For example, one of the things I'm from our own experience, and I don't know how other batteries have seen it, but there's definitely a tendency in the day-ahead market to drain batteries to low states of charge at the end of the day. And in a world, a future world in which there's a need for batteries in the early morning hours as well as the end of the day, there will be, I think, a need for CAISO to guarantee availability for the following day. And so a product like this would allow an end of hour 24 firming requirement for which people could be paid, and it would essentially support keeping some charge on batteries especially when you're trying to coordinate between the need in the peak and the need at the end of the day. Prices are the best way to do that. It will be sort of unilateral, requirements that batteries be charged at a certain level are going to have the same problems that MSOC does right now. Also, I think there's the possibility that something like this could help, as I said earlier, compensate long-duration storage, which is inherently not going to be fully represented in the day-ahead market. So assuming that we don't switch from the current 24-hour horizon to a longer binding or semi-binding market horizon, there is an issue of how we compensate resources that are actually charging in the market to maintain reserves. For something like Helms, we essentially have a good assessment of what the value of the resource is going to be over many months, and we're able to adjust from any one day to any other day because of the large size of the reservoirs. But if you have long-duration storage, which is fairly limited in its energy capacity compared to a pump storage plant, then there's much more of a need to assess how you pay for charging in the market. You don't necessarily have the alternative of saying we'll just not charge at all today. You may have to do some charging in order to retain the value of the long duration storage. And it's even possible that a requirement like this, if it were defined on an hourly basis, when combined with other inputs to the markets, namely the load forecast, the renewables forecast, other AS procurement requirements, and perhaps also representation of demand that is richer than the current representation of demand, could really enable stable and efficient pricing in what's being called, it isn't really, but a zero marginal cost electricity market, or in other words, a market where all of the energy is being produced at zero marginal cost, or effectively all, and then through efficiency losses at some variable cost, that energy is being shifted to all the other hours of the day. And I think that's the last slide in my deck. Thank you.
Well, thank you, Alva. That's a great presentation. Certainly a lot of ideas to digest there. And yes, we have had a few conversations about some of these ideas. And I think I am thinking about similar type solutions to what you're outlining here. And these may appear in the straw proposal of the next phase of this initiative. I also agree that I think some of the questions you sort of put out there and said, well, you have to define the requirements, and then you have to think about times when you want to impose the requirements. I think those questions are still hanging out there for me as well. So there's a lot to kind of think about and still work on and to craft if we are to move forward with a proposal like this. So yeah, I think lots of good material here, though. So I really do appreciate you presenting and putting these slides together.
Thank you.
One question I did have for you, though, is, well, I guess first, would you care to speculate on ideas about setting the requirements and when they should be imposed? And I think the other thing you mentioned was sort of RA obligations, sort of in context with this presentation.
I think my first inclination would be that they would be done very much like other ancillary service products.
Mm-hmm.
That there would be either a forward-looking analysis by CAISO that would define kind of the level of need that you would expect to have, and then based on other forecasted system conditions that might be a way to define the need on a daily basis. I don't think, obviously, I don't think you can go to my longer term vision, or potentially not even to the end of day, without having really seen this, be a robust product just for your own purposes right now, which is essentially to guarantee, energy in the peaking hours. And I think that might be easier to do and a target for where to implement initially. And also, it might be more straightforward to say that requirement applies to batteries within some range of hours in either the RA process or just in a must-offer framework that essentially batteries that are must-offer have to provide a bid for SOC firming, and then the question would be how you would constrain that bid. But I think that would be my starting point for that.
Yeah. Thanks for that feedback. I appreciate it. The other things that I think you mentioned, and I think also are things that I've been thinking about a little bit, is yes, as we move to long duration storage, this could potentially be a tool that we use to help with that. And I think the point that you made about, well, procuring energy from the previous day to go into the next day, is also going to be relevant and necessary at some point in the not-so-distant future. So I think that's useful as well. The other thing that I've been thinking a little bit about and talking to some people internally, well, and externally about, has been this sort of $0 marginal cost generation future and what that looks like, and other potential market features that we might need to sort of accommodate, such a future. I don't think we have enough time to quite get into that conversation today, but I do think it's relevant, and I think that that's a nice sort of segue to a future conversation as well. So I appreciate you bringing that up. I know we just have a couple minutes, so maybe I'll turn it over and see if anybody else on the line has questions, and then we can check on either questions in the chat or questions on the phone.
So, yeah, I have a quick question. Alva, thanks for the presentation, by the way. Slide 3, I wanted to understand, you have a constraint on the state of charge, and presumably that will result in a shadow price that will be paid to those who provide it. The price of SOC in slide, I think that's slide 3, maybe it's the next slide. No, the one that has the DA, there we are. The price, sorry, is the price an offer by an individual battery owner saying I'm willing to sell state of charge, or what is this price in the objective function?
Yeah, well, the bids would take that form, and then it would clear at the shadow price based on those bids.
Okay. Right. I got that picture. So I just and the other thing I want to get is a reaction to the following statement. So if I have a perfectly flexible resource that could provide energy during the evening peak, but clearly that provides the same value as energy from a battery with the same capacity, same value. So it would be discriminating not to pay me as well as the battery for that. Do you see then that any resources that can provide energy during the evening peak would be able to get this shadow price, maybe subject to some capacity constraints or something? And in a sense, would you view this as a way to let's say the price is at the price cap. This is a way to, in a sense, pay more for energy during the evening peak than the price cap allows, which might be a good thing. But anyway, I'd be curious any reaction to that statement.
Well, that's an interesting another complication. If you restrict this to SOC managed resources, then they're not getting paid doubly for the energy. They're getting paid for being at a certain point in their state of charge at the beginning of the period. There's no real equivalent to that preparedness for unconstrained resources, or there probably is, but I don't know how you frame it in a way that you have that same level of guarantee. But if you do, then it would be you're essentially paying for that for the guarantee day ahead, just much as we will be paying for imbalance reserves and flexible ramping reserves in the day ahead market enhancements.
Mm-hmm. Okay.
And you could do those as when a resource gets used for energy in those same hours. There's always been the question of double payment there. I don't see it as double payment though. I just see it as because it's being optimized for based on a different set of bids. It's a different cost in the market model that is being compensated for a particular service. It's not energy.
We'll have more opportunity to talk about this perhaps in the future. I'm definitely interested in this concept, but this troubles me. So I'll yield the floor and see if there are questions from others. Thank you, Alva.
Thank you, Ben.
All right, and for our participants today, if you would like to ask a question and you are in the WebEx, feel free to raise your hand. The raise hand icon is located to the top right of the chat box. And of course, you can put a question in the chat and direct it to all panelists. And finally, if you are phone only and not on the WebEx, you can just press #2 to enter the queue. All right, and I'm not seeing anything as of yet.
Yep. Thanks, Adam. Appreciate that. And thank you again, Alva.
Thank you.
Great feedback, folks. Great ideas. Carrie and Alva, and I believe next we have Sergio from CISA. Sergio, whenever you are on, let us know, and we'll confirm that we can hear you.
Hi, can you hear me?
We can.
Great. Okay, excellent. I'll get started then. Well, good morning, everyone. First off, I'd like to thank Gabe, Jimmy, the whole ISO team for setting this up and having stakeholders talk a little bit about their perspective on this initiative. If we can go to the next slide, please. Oh, it seems like my deck's not showing.
Like you have. Hold on a second, Sergio. Let me. Yeah, I might have to have a PowerPoint for animation. Hold on one second.
Sure, no problem.
Hey, Adam, we have a PDF. I'm not sure if the PowerPoint's available. Is that going to be an issue sharing the screen, or do you have suggestions on how to
I'm sure.
show it without?
So if you are screen sharing the file,
right.
it should be fine if it's a PDF. But I assume the issue is with your computer or somehow related?
Interesting. Yeah, I don't know. Let me, I guess, close and reopen it. Hold on one second.
I can also see if it'll look different on my computer. What is the title of this
Yeah,
presentation?
it's fine. Back into the slides. I'm going to pull it up maybe. So I'm not sure. I have Adobe Reader and everything. It didn't give me an error, so I'm not sure what's going on. Sorry,
okay,
folks.
I do think I might have a way to display it.
All right, thanks. Yeah, it's the CISA presentation.
Yeah, no problem. Give me one moment.
Sure, thanks. Okay.
All right, it might not be perfect, but it's better than before, I think.
Yes, much better.
Yeah, we can definitely work with this. So as I was saying, good morning. I'm Sergio Dueñas. I am a senior regulatory consultant for the California Energy Storage Alliance, CISA. Today, I'd like to talk to you about our perspective on some of the issues that are considered in scope in this initiative. I will be focusing mostly on the replacement for the MSOC, but I'll also talk a bit about who we are at CISA, what is our perspective on the changing storage market, and what are sort of the options that have been communicated by the ISO that we think have merit and that should be explored a bit further. I think we're treating this particular day of presentations a bit as a learning opportunity as well, not only for us, but our members and other stakeholders so that we can better understand what are the challenges from the ISO perspective and market participants as well. So if we scroll down a bit, I just wanted to introduce everyone to CISA in case you haven't heard of us. We are 100 members strong. We are a membership-based advocacy group that is strongly committed to making energy storage a mainstream resource in the state to promote a reliable, safe, affordable, and clean electric grid. We've been pretty active in the ISO initiatives, but also at the CPUC and CEC. And really, we are supported only by our members, and we are technology neutral. So we have people, as you can see, scrolling a bit down, we have members from all across the energy storage industry, different levels, working front of the meter, behind the meter, operators, developers, manufacturers, etc. So today, what I'd like to do is share a bit of our members' perspectives and communicate, what we see as modifications that the ISO should consider for further development. So first, to set the stage a bit, if we scroll down to next slide, I think, as you know, the state, California, we have very ambitious climate and energy goals. For the size of the California economy, we are really betting on really rapid decarbonization and meeting targets that are way more ambitious than other economies of a similar scale. To do this, a lot of storage has been integrated into the CAISO, particularly according to data of the ISO. By September of this year, we'll have almost 2 gigawatts of grid-connected storage. That is, of course, I'm referring here to battery storage that is incremental to legacy pumped hydro. But if we were to consider that as well, the state really right now is seeing a very important increase in storage interconnections. This makes us really excited because storage is obviously poised to help with decarbonization while maintaining reliability. It can allow us to, use excess renewable energy later on, reducing reliance on meeting local resources and supporting the ramps that we're seeing. However, right now, storage being such a novel resource that actually is, very dependent on its value given other grid conditions, the rest of the grid mix, and of course, the rules and processes and frameworks that we have. All of them have been designed for conventional resources. So storage, while promising, is locked in a way. A lot of its value is locked or being blocked by a market that has not been thought of for this type of resource. So at CISA, the way we view this challenge is mainly as what do we need to get going? What do we need to start doing so that we can ensure that the value storage can bring to the table is actually utilized. With that in mind, we really welcomed the the initiation of this initiative to start considering different modifications to currently known problems, a couple of which I'll talk about in my next slide. So we can scroll a bit further down. Yeah. So as you know, storage is not a generation resource. It is a bidirectional resource that is able to absorb and discharge energy later on. I think the way that a prior presentation put it is it's very well said as storage is a pure arbitrage product. Because of this, storage compared to conventional generation assets storage doesn't have a marginal cost structure that is similar to, for example, a regular thermal power plant. A variety of factors affect marginal costs in ways that are not currently considered by the ISO in its bid curves, for example, such as cycling, charging costs, and of course the state of charge of the resource. Right now, batteries are not able to fully reflect their marginal costs, particularly because at different points of their operating cycle, they will be having, variable marginal costs. By this, I don't mean that conventional resources don't have variance in their marginal costs, but they're not as multifactorial as storage assets. In this context, and this is something that, of course, the ISO team and stakeholders here can find in our own comments to the issue paper, we've recommended as a potential fix to this issue to allow storage to submit multiple bid curves that are dependent on state of charge or cycle, either or both. Something that is another alternative that has been commented here is to allow storage assets to update their bids with more frequency. This is something that has been considered in other ISOs. For example, in ERCOT, it's something that is viable. However, as noted in the issue paper, it might be unfeasible to apply a modification of that magnitude. And as CISA and other parties have noted, we're very interested in having fixes that can be implemented in the near term, even if they are incrementally better, right? We can start with some form of modification, both in this topic and others, as I'll cover later, and then keep evaluating always by data how we're doing. So if allowing the continuous update of real-time bids is something technically complicated, we think that this is a viable strategy, just having different bid curves that are dependent on the SOC or reflective of it. A second issue that we've seen in scope that is not related to the MSOC, but it's important for us, for our members, and we've seen a lot of interest in addressing this issue as it relates to potentially capturing loss of revenue, of opportunity costs, for example, or other costs related to what could be potentially inefficient dispatch. This has to do with bid cost recovery, which right now is calculated using a settled cost and revenue across the day. While this approach is potentially applicable to energy storage, something that we've seen and that we've heard from our members as well is that it doesn't quite catch instances in which there has been dispatch instructions, be it by the multi-interval optimization issues that we've also discussed and addressed in our comments, or more broadly, if we were to have something like an MSOC application today, this wouldn't be able to be captured in bid cost recovery over a full 24-hour period. Something that we've proposed is to net all costs of charging the resource with the revenue from discharging the resource and comparing that to the bid spread that has been communicated by participants. While this is something that could help us better understand the potential of bid cost recovery for storage and address it, it's important to note, as other presenters have done today, that this might be even more complicated for longer duration resources, as other modifications considered in this initiative would. And this, of course, has to do with the nature of our market that is focused on single day operations, and then going into more granular timeframes from the day to the hours to the 15-minute intervals to the 5-minute intervals. It's more complex to capture the activity of resources that have an operating cycle that could extend over a day. And this takes us to the third topic, and the one I'll talk about the most today, which is how do we consider upcoming conditions and dispatch resources effectively and efficiently, considering what's coming up in the system. Today we have this issue where we could have storage being inefficiently dispatched or dispatched too soon, despite its need. And it seems like the question for us in this part of the initiative is, how do we incent desired outcomes while we also compensate for the opportunity costs? So if we go to the next slide, I have this graphical sort of description borrowed, of course, from the ISO, showing what the challenge is from CISA's perspective. The current market formulation basically puts us as a grid. When I say us, it's the system as a whole, in a situation in which prices are rising from the early afternoon until about 9 p.m. And then prices may decrease, but really the load conditions continue to be substantial. And with a growing reliance on renewable intermittent assets, that blue area that you're seeing on the right side of the screen will only get larger. The risks of not being able to meet load, particularly after the peak, but during the net peak period, is something that we think will increase as we move forward our decarbonization efforts as a state, and we start seeing more conventional resources become substituted for storage and intermittent generation. Right now, what we've been seeing, and partly you can reference this looking at the data from the current MSOC, is that these instances are not that common. However, that doesn't mean that they won't become more common later on. So with this in mind, CISA was supportive as a preemptive measure of having a very limited tailor application of the MSOC that focuses on the days with the biggest risks, which is what we have today. And we think that that is a mindset that we should continue having in developing our replacement, something that can be thought of as a potentially extraordinary measure currently that will become more frequent as the years go by and we start seeing a much bigger overhaul of the grid mix. So if we move to the next slide, I wanted to show you and share some of the principles or thoughts that we've had in mind within CISA and with our members when thinking about replacements for the MSOC. We are, as an association, the voice of storage in the state, we are fully committed to ensuring that storage will contribute to reliability. But we do think that any method that wants to preserve state of charge should be market-driven, a market-driven solution that is dependent on prices. Here, I'm using prices as used in the presentation by Gridwell, should be reflective of market conditions. It should respond to those conditions. The second bit is that it should compensate storage not only for the service rendered in maintaining SOC, but also for the opportunity costs of rendering that service. And finally, it's important that we balance the need between having certainty of that storage will be charged and ready for that period, but also the need for flexible and responsive capacity that will be needed in the real-time market every single day for regular operations. So with that in mind, we've seen a couple of proposals by the ISO. I think we can skip the next slide and just go to 10 directly. We've seen a couple of proposals, and I'd like to focus first on the energy shifting product. In this product, the idea would be that the CAISO would procure some amounts of energy in the day-ahead market, so that from the energy storage fleet, and every hour that storage is bidding in the day-ahead market, they would be able to internalize their opportunity costs for basically being out of the RTD. If storage clears this product, the ISO says that a requirement would be imposed in the real-time market just to prevent discharging below a certain amount. We believe that this proposal is promising, this option is promising. It aligns with some developments that we've been seeing in the RA framework, such as basically having more clarity in the hours in which storage would be performing diurnal arbitrage. And it also eases, in a way, implementation, since as we see it today, the daily quantity could be based on the shortfall that is identified from the ROC analysis. So basically, we could use something like the methodology we have today for the MSOC. Let's run the ROC, see what the shortfall would be. That would tell us today what's the target for the MSOC. And in this scenario, it would tell us what's the daily quantity that should be purchased. For many days, this quantity would be zero. So storage would continue participating in its regular way. But for other days, when the quantity is non-zero, the resources that have been cleared for providing this would be needed in the real time to be somewhat modeled or visualized a bit differently. In the issue paper, the ISO notes that it's unclear how this would be, for example, a 5-minute product, or how this could be visualized in the real-time market. CISA, as a first step, we see it as it could be included or seen as a self-schedule. That would, first of all, really drive home the idea that developers, owners should internalize fully their opportunity cost of not being in the real-time market. But also it provides this complete certainty for these resources that they'll be available to provide this product specifically, while the rest of the storage fleet will continue operating normally and being able to provide the flexibility the grid would need in real time. A second option that I'd like to go a bit deeper here is in the next slide, has to do with this biddable stored energy product that I think in recent conversations has evolved a bit into an idea as more clearly as an ancillary service within the real-time market. I think from CISA's perspective, this is the way we're understanding it is we would have an inferred need that could happen either in the day-ahead market or during the real-time market. Based on that inferred need, we would be able to have a product that is priced at the marginal resource clearing. And it could be a bit easier to do this, since as an ancillary service, you don't need to keep tracking of a specific product, but the total need is allocated much more spread around a lot of resources rather than 1 or 2 or 3 that may be at risk of outages. We see this option as workable as well, as viable, but we do think it could be more complex to implement than the energy shift product. And it will also require owners of the asset to be a bit more aware in real time of the opportunity costs of their own resources. I'd like to hear a bit of what proponents of this idea to have to say about that, because of course this might be more of a question on our end than an actual issue. Something also that we wanted to raise here is that an approach like this might require deliverability considerations. We know that deliverability analysis are done for peak periods today for other ancillary services. But since this might not be effective only at peak, but also in off-peak periods, it might be that other resources or studies might need to be considered. That is definitely a question that we have for ISO staff. So while we do think that this is viable as well, it seems like the energy shifting product could be a tad more straightforward in its implementation, and it would allow us to start off as we are today, focusing on exceptional days, focusing on the days where something like this is actually indispensable, and then learn from that application until we can expand it later on in a more clear fashion as a full-fledged product, and not a product that we're only procuring in days where we had a perceived insufficiency from the RUC. So the next two slides, they sort of cover our position from the issue paper and a summary of what we've communicated here today. In the issue paper, we supported the list of issues put forth by the ISO, but we did recommend a two-phase approach. A two-phase approach that is somewhat similar to what was discussed by Gridwell too. So first, we should prioritize issues that are currently affecting energy storage, BCR, MIO, spread bidding, the way that we can characterize marginal costs, and focus on doing that by the end of this year. And phase two would focus on assessing the effectiveness of different solutions to replace the MSOC, and also considering a more long-time view on the look-ahead horizon issue, that a slide that I skip here for the purposes of time. But we did favor a development of something like the energy shifting product, which could be modified by near-term modifications pursuant to that phase two I mentioned. Given the evolution that we've been seeing in the RA framework, in the Commission, and also here with summer readiness, if we can go to the next slide, please. So given the evolution we've seen here, it seems like the ISO is more intent on actually prioritizing the MSOC. We don't think that that is completely ideal, since a lot of current issues need a bit more guidance. But we understand that if the ISO thinks this is something priority, we should still maintain in scope all the other issues where parties expressed concern in response to the issue paper. So even if now we're sort of turning to replacing the MSOC, the other issues should still be in scope and maybe considered a bit later, but they should still be considered. Another point is we do think that at its core, extending the real-time dispatch look-ahead horizon would really solve a lot of the issues that we're talking about here. But it does seem that this is not technically feasible at this time. So for these reasons, we do recommend focusing on the energy shifting product or the biddable SOC product, although we see some advantages for the energy shifting product. It's easier to understand and to internalize costs. It won't really affect co-optimization of other services in the real time if we treat it as something like a sales schedule. It provides the ISO and the LSE's buying storage certainty regarding what storage is going to do. And it also balances this flexibility quite well, since not all resources will be needed to bid into energy shifting, as we can start that from the insufficiency or the rock deficiency that we find. So with that, I'll leave it up to Gabe, Jimmy, if you have any questions. And I actually made a pretty question slide at the end that we can keep there. Oh, sorry, I had a final slide on additional feedback from our members. A topic that some of our members are pretty interested in, and it's really a question that we have for ISO staff, is how MSOC today and successors as well interact particularly with co-located storage. It seems that both the MSOC and any replacements that we've talked about in this presentation could require storage, mainly co-located storage, since it's visualized as its own asset, to charge from the grid. And this could have very significant impacts on costs and revenue streams that developers are considering in their projects, such as the ITC, but also California state taxes. So we'd like to raise this and maybe consider it in this initiative as well. I know, Gabe, you mentioned that this would be more thought of in the hybrid evolution initiative. Perhaps for hybrids, that is the most adequate thing. But I think in the case of co-located storage, since it's being visualized as a unique asset with its own resource ID, this might merit some analysis for the straw proposal.
Yeah, Sergio, thank you so much for your presentation and for the thought that you put into the slide deck and some of your comments. I really do appreciate it. As far as, just to address one thing that you said on the last slide regarding the ITC, we are certainly going to spend some time thinking about ITC and ITC implications in this initiative. That is something that Susan Schneider is going to be presenting on this afternoon, but it's also something that we've heard again and again from both parties that are developing resources and are trying to finance them today and get them online and operating on the grid, and from resources that are already on the grid trying to capture some of these benefits from their resources. So we do want to take that into consideration, and we will be talking about that in the straw proposal and hopefully come up with some good suggestions there for that. And we will continue that conversation this afternoon. But I did have, and I know we are actually a couple minutes over right now, but I did have two questions specifically on the Energy Shift product. The first question would be about pricing for the Energy Shift product. Would you believe that prices would be the same for energy that's scheduled in the day ahead as they would be for the Energy Shift product? My thinking would be that the Energy Shift product would also include some kind of an opportunity cost, because like you say, that would likely result in a self-schedule in the real-time market and wouldn't be something that you, or something like a self-schedule, and wouldn't necessarily result in something that you could potentially reschedule. And then my second question would be, how do you differentiate who gets the awards for the day-ahead energy, just regular day-ahead energy, versus awards for the day-ahead energy shift product? And obviously, if they're both bids, then perhaps co-optimization would be fine. But if it's the same bid serving for both, how does the market reconcile that?
Yeah, thanks for that, Gabe. I think those are really good questions. The first one, I completely agree with you. I would expect prices to be slightly higher for a shifting product than just normal energy. And this mainly has to do because of that opportunity cost adder that I think here it's something that we've had a lot of trouble at the ISO discussions trying to hone into, trying to calculate it in a very sophisticated way. But I think under the energy shift idea, each owner would have to actually do that calculation for themselves and internalize it. And, you know, their bids will be in their responsibility. So that's something easier from, I think, a market participation perspective, but also easier for you guys technically. I think that could be something really positive about this. On the second point, well, first, I'd say not every single day would we need to care or analyze all the bids for energy shifting. I think our idea, our visualization of this product is that it would only matter really when we find something as today with a rock insufficiency or something like that. Then we need to look at what is the stack of bids, what are the people, the resources that are actually offering to do this at the lowest price, and other bids for energy, they will keep flowing in a regular basis, you know, every single day. Really, the bids for energy shifting, I expect, will be something that occurs and is important, and we need to clear and find those resources on a couple of days, maybe some days during summer, but it will increase later on. And with that, we can keep perfecting this product. I think what we're thinking of here is let's shift from something that doesn't capture opportunity costs at all, what we have today, to something where the owner can internalize their own opportunity costs and they'll have a bit less. Yeah.
Yeah, I appreciate those comments, and I think regardless of what solution we end up implementing, you're right. The ISO does not see whatever constraints we're going to impose as something that would be binding for like this year, next year, the year after, even on most days. It would be, you know, the hottest days when system conditions are really tight, and it would be and we would be dependent or critically reliant on storage resources to meet net load peaks. So we don't envision this, at least initially, being something that's used terribly often in the market. But you're also right, it would be an opportunity for, you know, and again, I think this could apply to either of the products, an opportunity to include things like opportunity costs if your stated charge has to be earmarked by the ISO. Well, Sergio, we are over time, but I do thank you for your presentation, and I think we'll move on to the next presentation if we can, Jimmy.
Yeah, thanks, Gab. I've been monitoring questions, luckily nothing in the chat, and thanks, Adam, for slinging back the presenting rights for me. Let me pull it up once I'm able to.
And you should have them back now.
All right. Oops, not that. All right, want to make sure Perry Servideo and Matt Smith from GS Associates are able to get on the line, an audio check.
Hey, Jimmy, can you hear me? This is Perry.
Hey, Perry, yes.
Great. Just check if you can hear Matt as well right now.
Might be on mute, Matt.
Matt, he doesn't appear to have his voice connected in WebEx. So, Matt, if you're on the phone, press #2 for me real quick, please. All right, you see we have him on the line. I'm going to unmute him right now. Hey, Matt, go ahead.
Thanks, everybody. This is Matt. All right.
Hey,
thanks, everybody. This is Matt Smith from GDS. All right, great.
All right, thanks, guys. Thanks again, Sergio. We have to go over a little bit. Sorry for the technical difficulties, folks. But Perry and Matt, please.
All right. Thanks, Jimmy. Thanks, Gabe, for having us. I'm Perry Servideo, GDS Associates. I'm here with my colleague, Matt Smith, one of our battery cost experts, also at GDS Associates. And I'll just say up front here, we work with various energy storage clients in other markets on their bidding strategies and ensuring cost recovery through market revenues. We build complex algorithms to dispatch distribution storage to lower consumer costs, and we do much broader work with asset owners and operators in performance, O&M, and technical commissioning. And in California, we work with clients on battery economic feasibility and interconnection issues. With that, I can try to get started. I know we have a lot of material we want to get through here in our time slot. So in this presentation, we will drive at two recommendations for the CAISO to consider in its straw proposal. First, I'll give a framework for thinking about whether we expect the short real-time market horizon to cause a battery to discharge early in the day. And then second, my colleague Matt Smith will walk us through what we see as a specific inefficiency in the current CAISO bidding interface for batteries that, if fixed, could bring benefits to both CAISO and battery operators. We move on to the next slide. Okay, so like I said, I'm going to talk about a framework for thinking about how the real-time market will dispatch a battery throughout the day. And in thinking about this, we went back to basics. We took a step back. We asked ourselves, well, why would RTD manage an energy storage resource any differently than any other resource? And it really comes down to the existence of the state of charge upper and lower state of charge limitations. And given the 65-minute horizon and these upper and lower state of charge limitations, we see three behavioral patterns: a normal use behavior, what we're going to call in this a picky charger behavior, and a picky discharger behavior. And really, this has to do with whether you are midway charged, near full, or near empty. And we'll get into that starting now on the next slide. Okay, here we're talking about this behavior, which I'm coining as this normal use behavior. We have, and in each of these three examples, I'm going to have the same exact battery, a 4-hour battery with 100 megawatt Pmax. And in this example, we say, okay, let's say this battery is midway charged. It's 50% SOC here, and it has a charge bid of $50 and a charge bid of $250. Because the battery is 50% charged and it's a big enough battery that it's more than 65 minutes away from being full and more than 65 minutes away from being empty, what we see is that the RTD will actually just treat this battery just as if it was any other resource in its optimization. And that means that if you're in the money on the charge, if prices are, say, $49, then you're going to get a charging dispatch. If prices are somewhere between your charge and discharge bid, then you're not going to receive a charge or a discharge. And then finally, if prices are greater than your discharge bid, then you're going to receive a discharge dispatch. So, this is the general case if you're more than 65 minutes away from a charge or a discharge. And what we're building up to is a way to look at, as the prices change throughout the day, how we expect these batteries to behave. So if we could go to the next slide. Here's where we're talking about what I'm coining a picky charger. It's the same battery, except now we're within 65 minutes of full. I have it here as 308.33 megawatt hours. I think that puts you at 60 minutes from full. And you have a charge bid of 50 and 250. It's going to be the same on each of these slides. And what happens whenever you approach full is, because this optimization is looking out 65 minutes, it's going to start to get picky about when it will charge you, understanding that it now has a limited charging capability. So the portion of the behavior that is impacted is when prices are within the charging bid cost. So here you see in these 3 bullets on the bottom, if market prices are within the charge bid, say $49, then there's this, you could think of it as an additional conditional here. Well, the battery will charge, but if the binding interval price is not the highest price in the RTD horizon, in this specific example. And there's no change really to if the prices are between the charge and discharge bid. There's no change for if prices are above the discharge bid. So, what you could observe here, and what I'll show on a graphical slide later, is that if prices are rising throughout that RTD horizon, then the battery will tend to charge when the charge bid is in merit, because that is the lowest price opportunity within the 65-minute horizon to charge. The last behavioral pattern on the next slide is what I'm coining the picky discharger. And you can imagine this is just the opposite of the last slide. Here I place the battery within 65 minutes of empty and say, 91.67 megawatt hours. I think that puts you about 60 minutes from empty. Charge bid, discharge bid, exactly the same. The difference here is that because you're within range of being completely discharged, the optimization has to get picky about when it's going to discharge you over the next 65 minutes. So you see, if you're in the money on the charge, you're going to receive a charge dispatch. If you're not in the money on charge or discharge, the battery's not going to charge or discharge. It'll be, sort of in a holding pattern. And then finally, what you can think of as an additional conditional here is that you could be in the money on the discharge, 251 on a bid of 250, and the battery will discharge, but only if the binding interval price is not the lowest price in the RTD horizon. That conditional here is specific to this particular battery that is set, within 60 minutes of being empty. So, in summary, you have normal use. You have, as you get very full, the optimization gets more and more picky about when it wants to charge you. And as you get very empty, the optimization gets very, very picky about when it wants to discharge you. The more full, the more empty you are, the more and more picky that optimization becomes. So if we can move on to the next slide, this evaluate expected dispatch over the day. What this sort of sets up is a way to look at what's going on over the day. And we can use these 3 behavioral patterns, which are defined by the battery's SOC as of the dispatch time, combined with the expected market prices over the horizon to get a sense of the expected dispatch of the battery at a given point in time. And that's where we can go to the next slide, where I'm finally, I think, pulling this all together. Okay, so here's, your general afternoon price curve going into the time that the CAISO needs energy the most in its net load, net demand peak hour up there at the peak of the curve. And here I'm just using, what a typical price curve would look like on a day on a stress day. And what you can do is you can kind of look at each of these moments during the day and look at that limited 65-minute horizon, which is the shaded green region in the middle, and you can figure out, what is that expected behavior of a battery that is midway full, of a battery that has a high SOC that is almost full, and a battery that has a low SOC that's almost empty. And you can see early on in the day, as long as the battery is within its charging bid, you're going to generally see a dispatch that is to charge the battery up. As you move to the right, let's say one segment to the right here, to that second highlighted RTD interval, now you have market prices that are between the in-merit charge and discharge bid. So any battery with these charge and discharge bids, given this market price, is going to be put into a holding pattern. So all three, regardless of behavior, will be put into a hold position. Moving to the third segment, the third highlighted RTD interval here, you can see now I'm in merit on my discharge because I'm above the top red dotted line. Prices are rising. Therefore, this is the most, what you're seeing is this is an opportune time to discharge the battery. If you are at a mid SOC, you're in merit, so you're going to be receiving a discharge. If you're a high SOC, you're in merit and prices are rising, so you're going to be receiving a discharge bid. Now, you could see that the very picky charger, the guy who's next to empty, is still in a holding pattern at this point in time. And as you crest the top of that price curve, more and more of those 65-minute intervals become more and more attractive for a picky discharger to start discharging. Now, I have it just placed over here on the right of the curve just to illustrate it, but you're still in merit on the discharge, and prices are now falling, so now is the most opportune time for a picky discharger to discharge. So this is, what we wanted to look at was the question of the limited lookout horizon and what we can expect a battery to do over the course of the day. This type of analysis would be made better if CAISO could provide all of the advisory interval prices to see what exactly that optimization is doing in that time. But we think this is a general case. You can look at the prices that you observe in the binding intervals over the course of the day. My next slide is just to highlight also, this is slide 9 now, that scheduling coordinators are also able to update their bids throughout the day. So as their price forecasts for later in the day come in, they could say, you know what, I would charge at a higher price, and they can follow this. They want to charge later and later into the day and save that discharge for the peakiest of the peak price hours. And this slide walks through the same thing we did on the previous slide. I don't necessarily need to get into it again, but I wanted to include this slide for anyone who wants to look at these slides after the working group. But essentially what happens is you charge all through that full first segment. Everybody goes into a holding pattern. You start to discharge the normal use behavior batteries and the picky chargers. As you crest the hill, now you're starting to discharge the picky dischargers, and then you fall back into your range of not in merit, and you go into a holding pattern and finally start to charge again at the end of the day. So with that, I wanted to highlight that, and we can talk about that maybe in the question segment. But starting on the next slide, I'd like to turn it over to my colleague, Matt Smith, to start talking about how we see as the current battery bidding interface as sort of a square peg round hole. And he's going to get into some of the cost elements of this. Matt, if you're still there.
Thanks, Perry. Yeah, I'm still here if you can hear me. Thanks, Perry, and thanks everybody for having us on and giving us a few minutes here. Yeah, so as everybody's all the previous presenters have brought to the surface here, we got a bidding interface that accepts dollars per megawatt hour, and there's a lot of variable costs with energy storage that we wanted to kind of break away and think about. And as we know, it's a function of how we're going to use the battery, what the use case is, and energy storage operators, they're without a set of assumptions or some certainty there, they're going to have to make their own, and oftentimes they'll think towards the worst case scenario so that they'll be made whole for their service. And if we can go to the next slide, please. So these variable costs, marginal costs, kind of come from a few different categories here. You've got your energy costs, opportunity costs, and some of those cycling costs. The energy costs are fairly straightforward. A lot of the previous presenters have spoken about that. It's your energy from the grid that's going to be used because of the inefficiencies of the battery, your pass-through. You'll have some losses there. more economical resources will be able to bid into a lower cost. Same with the parasitic or auxiliary load. And I'll kind of skip over the opportunity cost for now. And what we really want to, the part of the marginal cost that I wanted to focus in on today is these costs related to the cycling. And yes, it's a function of a lot of different variables, and it depends on different kinds of products. Even lithium-ion products don't always behave the same. You've got different classes of chemistries in there. I heard some other interesting chemistries get brought up before. I've seen some of the zinc chemistry starting to emerge for longer duration and slow batteries, and others still. And so those are all having different performance characteristics, different state of charge sensitivities. Yes, lithium-ion has to slow their power rate down towards the top, and there's different products that behave differently, and also the economical lifetime of the asset is going to have different variables there. In particular, you've got all the costs related to the run hours of the equipment. If you run the equipment harder, you're going to have increased maintenance intervals. For example, you got all the HVAC on energy storage or thermal management skids. And then you've got, obviously, your degradation. With most batteries, every time you cycle them, they lose a little bit of their energy capacity. Degradation, as you know. And there's some batteries that don't have that problem, by the way. But lithium-ion does have degradation that an operator would need to account for in their life cycle management strategy of the battery, be it sizing it up front, oversizing it, or the way things have been trending. We're going towards a modular design, which can be augmented as the future goes on, and we can understand how the battery is used and as the batteries degrade. So on the next slide, please. Just wanted to go into a quick O&M example, so we're talking, so you understand what I'm talking about when I start. I'm going to mention the marginal cost and how those sort of break down, and this is how I'm thinking about it. You know, for when you're running a battery system, they're really easy peasy to run. I mean, you've got 6-month maintenance intervals, you've got HVAC repair and this kind of stuff. And you've also got potentially some major overhauls of equipment. So HVAC only has a 10-year life, for example. If you're running it harder, you could shift that life. Same thing with the inverters or some of the major components within the inverter. You could shift the life of those projects a little bit, and you could shift the end-of-life costs too. So driving the unit towards the end-of-life sooner than you thought, maybe you could shift those decommissioning costs sooner. And here's just a graphic. It shows us, you know, what these expenses look like as a percent of CapEx over a 15-year useful life, and you can see those gold spikes there. That's where I've modeled in the cost for replacement of equipment, and then all the decommissioning costs at the end of life. And then the smaller bars that you see here, this is the impact to the battery. So this is the operator saying, okay, we've used up this much energy capacity this year as far as our degradation. We're just going to go ahead and put a new skid of batteries down, and that's what that cost is. So those are those variable costs, you know, that we're considering on the marginal cost that we feel could be impacted on the way we're using the unit. And if you can go to the next slide, please. Battery degradation, this is a little bit of an eye chart. This is some of the output table from our battery degradation tool. And really what I wanted to highlight here, we don't have to get into all these numbers, is that the degradation rate is really going to depend on how you use it. You know, if you look at this first area here where it says the 2-hour rate, we've got degradation per hour is what I have here for different use profiles. So on the left, we have your average state of charge, and on top, we have your depth of discharge. So that one that's red, 0.0124%, that's how much your battery degrades in 1 hour if you're going to go from 100% state of charge to 0% state of charge, right? So you're at an average of 50%. And then you can see for like a shallow depth of discharge, like 25% on the high end. If your average SOC is up by 75%, you get about a 2 times the degradation rate as you do at the lower end. Same depth of discharge, just providing that same amount of energy over the same amount of time, same power. You just get a little bit different degradation rate because of their average state of charge sensitivities. And as it was brought up earlier, yes, your charging rate goes slower, your efficiencies are worse at the higher state of charge too. So there's those kind of marginal costs to consider too when you're operating at a higher state of charge. And we can go to the next slide, please. So this is when Perry and I got busy working on the whiteboard, and we said, well, you know, this asset can be used in a lot of different ways. You know, in case A here, it could be used in a fairly moderate way. Where at the high end of the state of charge, there could be a lot of marginal costs associated with the charging energy here or some inefficiencies. However, cycle B is a very deep depth of discharge, where it's, you know, maybe doing some intra-period activity as well at a higher power rate. So this sort of scenario would cause a lot of different degradation. And we started thinking about, well, what would that actually be? Let's take a shot at quantifying it for a few scenarios. And if you can go to the next slide, please. And so this is what we ended up doing to help us think about it and illustrate the example. We created 3 different dispatch cases. If you look at the plot to the left here, we've got a moderate dispatch case, an aggressive dispatch case, and just a really low impact case. Yeah, you're up there at the high end of the state of charge, and followed in the next period by a 50% depth of discharge. And cycle B, very aggressive. It's going up and down. It's got probably the amount of energy, that's about 100% depth of discharge. And then you've got the low impact case, almost like a C over 20 rate or a 20-hour rate. You know, there's barely any current going through that. And by the way, you know, your battery is always degrading, and the slower you get, you kind of drift down towards the calendar life degradation rate. So we think about costs and relative to what is the lowest potential impacts that we could have to the battery, and how much more did these particular cycles cost us. And we went through the dollars and cents exercise, and just to illustrate the example, we've got some relative difference relative to the low impact use case. And yeah, for this example, the moderate dispatch case is about 10 times more the marginal, those variable costs. And the more aggressive case is 27 to 31 times, so about 26 times the marginal cost. And so that, you know, that ends up being a portion of that bid, right? It's you know, you're allowed to bid in this square. Well, we're dealing with the square peg round hole, and this doesn't quite fit in there because our costs don't really represent what it's actually going to be if we're just bidding a flat amount. So we can look at we can look at that and actually consider that in the way we bid. If you can go to the next slide, please. I see that we're running low on time, and this brings us to our summary slide. So Perry, perhaps I can hand it back to you at this point. You can tie us up with a bow.
Sure. Yeah. This should now be obvious after the last few slides that, you know, we would recommend that CAISO looks into the benefits and feasibility of the following bidding interface enhancements. I know that you guys have put some work into feasibility of moving the bid due time closer to the dispatch interval, but what we're hoping to illustrate here is that could actually bring some big benefits to the storage community. And the second thing that we're highlighting here is that, you know, perhaps you should investigate looking at allowing, you know, basically a second bid parameter that's a function of average state of charge and depth and discharge as we showed in that table previously, that the market could treat as an adder to its normal dollar per megawatt hour throughput bid. And, we think these things would bring some benefits. We haven't quantified them, but, what you could look for is how much more accurate marginal cost information that the CAISO could receive from resource owners, and then also what the CAISO gets out of it would be a more efficient, flexible dispatch. So I think that's our last slide, and it looks like we kind of nailed having maybe 5 minutes left to talk about some of this stuff, or take some notes of things that we could go look into further.
Yeah, thanks, guys.
Yeah, go ahead, Gabe.
Oh, I was just going to say thank you very much for the presentation. I think it's very insightful to see, some of these examples about how storage resources might work and might participate in the markets. And then it's particularly helpful to see quantifications of, those different costs and how they relate to actual operations of the storage resource. I do know and would reference that in ESDR 4, we did specifically talk about having bid adders that would be automatically applied to storage resources bids, specifically in relationship to depth of discharge and or potentially state of charge. Here in this initiative, we certainly have, in our issue paper, we talked a little bit about bidding and how those bids, how we might get some more information closer to the actual market time and how that might be desirable for storage resources. So I certainly think that these questions and these asks for enhancements are good, and I think that they are certainly well within the scope of this initiative. So I thank you for bringing these up as points to consider. I do see we're at 12:20 right now. I might just ask if there's anybody else from the ISO who has any questions, and then maybe I'll turn it over to Jimmy to set us up for lunch for a break, and then we can adjourn for a while. Anybody else from the ISO?
Thanks, Gabe. As a reminder, folks, push #2 if you'd like to make a comment. Nothing in the chat.
And folks can also raise their hand using the raise hand icon of WebEx, if that is their primary method.
Okay, Jimmy, maybe we should wrap up for lunch then.
Yeah, thanks for being on time, folks. Just a little bit over, but we did build in that we had to catch those tech snags. So, folks, looks like we can get started right on time, 15 minutes past the hour. So we will see you shortly. Thanks so much again to all the presenters.
Thanks, Gabe. Thanks, Jimmy.
Thanks again, Perry and Matt.
Jimmy, quick question.
Thanks, everybody.
Yeah, operator, can we move on to the private line first? I think we had a question on the back end.
No problem.
Thanks. All right, good afternoon, folks. Thanks for your patience as we are pulling up the next deck. And I want to introduce Brad Dusick from Vistra, who will be presenting the next deck. So we are right on time, and we want to make sure everyone has equal amount to present. So Brad, please go for it. I think, Brad, you might be on mute.
This is Brad. Can you hear me?
Yeah, there you are. Yeah.
Okay, perfect. Go ahead and go to the next slide if you don't mind. All right, great. Thank you. This is Brad Dusick with Vistra. We appreciate the time this afternoon to speak with the group on the proposed enhancements to the energy storage there in the CAISO market. So thank you all. We do believe that this is a phased approach where some of these items should be addressed near term while continuing to work on the mid and long-term solutions. While operating our Moss Landing battery facility over the last few months, we've discovered two practical challenges with operations. These practical challenges should be the near-term focus. I will say over the next few months, while we continue to operate Moss Landing battery, I'll note with additional market experience that it will be more clear what issues need solutions to the NGR model, but these should not delay addressing the known operational issues that we know today. These would be more of a midterm focus. Lastly, what solutions are needed, if any, to market-wide functionality will require time to determine and should not delay, once again, the focus on the near-term items. These issues would be effective, all limited resources where their limitations cannot be captured by the current real-time horizon, as well as real-time market limitations and capturing daily use limitations or charge limitations. Those should be a long-term focus, and we'll look forward to continuing to work with on these issues with the stakeholders in CAISO. Next slide. This slide is just a walkthrough of this phased approach. I'll note that today we plan on focusing primarily on phase one. Phase one is broken into two implementation target dates. The first, as soon as possible, but no later than Q4 of 2021 for elements that would not require FERC tariff changes. The next target dates would be Q2 of 2022 or sooner for elements that would likely require FERC tariff changes. Phase two would be fall of 22 target, and this would explore the NGR functionality that may be resulting in storage operators observing inefficient market outcomes and or limit its ability to ensure it holds sufficient state of charge during periods of highest real-time need. Phase three would be the long-term, fall of 2024. As mentioned before, if through further experience it's realized that there is sufficient benefit from broader enhancements to the real-time market design to better capture the use limitations. Next slide. The phase one operational needs we'd like to discuss today are: one, adopt a dynamic modeling of foldback, the impact on the PMIN and PMAX. Resource modeling should reflect foldback impacts to minimum operating level PMIN and maximum operating level PMAX when the battery is at the low or high end of its stated charge. We would expect that this may require FERC approval and would fall in the Q2 of 2022 or sooner. The next would be to specify exceptional dispatch rules where require specific treatment. ED rules specific to out-of-market dispatches for batteries should be included in a tariff, recognizing the unique characteristics of storage. This, too, we would expect to require FERC approval and would fall in the Q2 of 2022 or sooner. Third, improve outage management system to better reflect outages. OMS should allow scheduling coordinators to better reflect conditions limiting battery operations. We would not expect this to require FERC approval and would fall in the Q4 of 2021 or sooner. Lastly, we'd like to address lessons learned after minimum state of charge event on July 9th. minimum SOC enforcement should be communicated widely to the market prior to the market day. We would not expect this to require FERC approval, and this would fall in the Q4 of 2021 or sooner. Next slide. The first item I'd like to discuss in further detail is the foldback issue. Once again, this would be the fall of Q2 22 target date. Batteries experience a foldback that reduces its Pmin or Pmax continuous amount when at low or high state of charge levels. When a battery is either high or low state of charge, the charging discharge current must be limited due to ensure the operating limits of the equipment are not exceeded. This would be change in Pmin, Pmax given the SOC is sloped. For those that aren't aware, this is an easy way to describe this would be similar to putting gas in your car. The pump will stop even though you still have room in the tank. Wait a few seconds and you're able to fill it back some more. We see those issues as we fill up or as we empty the batteries. Today, we can only manage foldback through outage cards. This is misleading since it's expected operations and not forced outages. It is burdensome on the battery operators since it requires chasing these Pmin, Pmax fluctuations and submitting multiple outages since this is a sloped issue. It's also burdensome on the CAISO operators since it requires frequent approvals. Near term, we want to see a solution where the market dynamically adjusts the Pmin and Pmax in a given interval based on SOC levels. Foldback impact can be estimated similar to ramp rates. Foldback may vary at a given SOC level across data points, but there is an ability to pick a reasonable value for registering a resource characteristic for modeling purposes. Also establish resource characteristics potentially as either a Pmin, Pmax given its SOC or a foldback rate given the SOC. Next slide. This slide is a mocked-up example of a foldback showing Pmin impacts. Please note the inverse is seen on Pmax when approaching 0% SOC, but not quite as severe. This is an illustrative example over an hour where at the top, the light green line is the SOC with the right axis, and the darker green line is the Pmin, which will be seen on the left axis. In this example, you can see around the 35-minute mark, once SOC approaches 95%, the Pmin moves off of the minus 100 megawatt and begins sloping up as we approach 100% SOC. We recommend dynamic modeling both reductions to the Pmin and Pmax to improve operations. Next slide. The next item we would like to discuss is specify ED rules where it requires specific treatment. This would also fall in the Q2 of 2022 target timeframe. Please note that the first couple bullets, CAISO customer service has communicated operations will perform this way. However, we are requesting for it to be formally documented in the tariff. First, a charge exceptional dispatch should not exceed the resource charging capability. Secondly, a discharge exceptional dispatch should not exceed expected SOC at the start time. If operations does not pair with a charge ED prior, then should not exceed current SOC level plus sum of any advisory charging or discharging schedules between issuing the ED and its start time. Also, as noted above, if operations does pair with a charge ED prior, then should not exceed charging capability of the resource. Next, for verbal exceptional dispatches not issued through ADS, ED should not start sooner than battery is able to respond in manual mode. The master file could be leveraged to reflect this response time. While the response time should be relatively quick, it's not automatic and it's not instantaneous, as an operator would need to be notified and have sufficient time to place the battery into manual mode. Lastly, for hold exceptional dispatches, all resources should be paid lost opportunity cost. Next slide. The next item go over is the improved outage management system to better reflect outages. This would be a fall of Q4 2021 target date, if not sooner. Allow batteries to submit overlapping outage cards across PMIN, PMAX, or max energy that allow use of various nature of work types. NGR experience capability changes throughout the day to PMIN, PMAX, or max energy capability that are driven by different causes. NGR need ability to submit overlapping outage cards so we can more accurately reflect changes to unit capability across PMIN, PMAX, and max energy by nature of work type. Clarify nature of work expectations and BPM to improve outage reporting. Batteries should be consistently using the same nature of work type to reflect similar impacts to PMIN, PMAX, and max energy, including but not limited to. BPM should specify which now should be used for inverter failures. BPM should specify which now should be used for foldback impacts until market solution is implemented, since it's not really considered a forced outage. BPM definition should note any card types that are inappropriate for NGRs to use. Enhanced outage cards for unit testing to reflect battery withdrawals prior to COD. Currently, we're unable to submit outage card with charge schedules. It requires direct communication with grid operations to ensure they're prepared for withdrawals instead of injections, as the card could be incorrectly understood due to these technical limitations. This is inefficient for both the plant operators and CAISO. Next slide, please. Final slide, we'd like to go over some of the lessons learned from July 9th MIN SOC event, along with our recommendations for greater transparency and clarity. This would fall in the Q4 2021, if not sooner, target date. On July 9th, the CAISO triggered a MIN state of charge requirement. We found this approach to notifying scheduling coordinators lacked an additional layer of communication needed as a backup. CAISO should send out a notification of MSOC is triggered to make scheduling coordinators and the rest of the market aware. CAISO should send a market-wide notification no later than 1500 the day before. This adds an additional layer of communication to ensure scheduling coordinators check the MRI report and increases market-wide transparency. Further, CAISO should not enforce SOC limits during hours when day-ahead awards begin. This would remove confusion and allow market to function efficiently to meet real-time needs. The next slide goes into this in a little bit further detail. In this slide, the light green line is the day-ahead LMPs. The dark green is the real-time LMPs. The axis on the left is in dollar per megawatt hour. The peach-colored columns are the MIN SOC directives leading up to a day-ahead award beginning at 1800 and lasting through the full day-ahead award commitment, rolling off each hour's obligation. The axis for the SOC is on the right in megawatt values. Although we had a full SOC after our morning's charge, CAISO began dispatching us hours 15 and 16 and then began charging us hours 1700 at much higher prices in order to meet the MSOC at the end of hour 1700. Had we been notified much sooner, we could have been more proactively managing our real-time offers to mitigate the risks of an earlier than day-ahead award discharge. The FMM intervals toward the end of hour 1700, where MSOC was driving charges, started at 900 and exceeded $1,000. This is an ineffective scarcity price signal considering discharge signals hours 18 through 20 on average were relatively similar to hour 1700 intervals. We also wanted to speak to the MOC directives for hours 18 through 20. These directives seem unnecessary and confusing as the MSOC accomplishes its goal by building up your SOC prior to the day-ahead award beginning and is not necessary after that. We recommend not enforcing during these periods once your day-ahead discharge hours begin. That concludes. I do want to say, there are areas for improvement, and we are encouraged and appreciate CAISO and the effort to collectively work with us and remain a leader among other ISOs as we work on implementing more energy storage into the ISO. I'll open it up for any questions.
Hey, Brad. This is Gabe Bartok from the ISO. First of all, I appreciate your slide deck and taking the time to sit down and walk us through this. You know, you've got a lot of information packed in these slides. I did have a few questions. I think, frankly, some of the conversations that we can have about these particular topics could be very, very deep. So maybe I'll just ask a couple of topical questions, but there are some additional things that I'd personally like to follow up with you on, you know, perhaps after this call. But if we go back, Jimmy, to slide 7, if we could. Yeah, we're talking here about exceptional dispatch and limits that the exceptional dispatch should observe. So I think the question that I have for you is, are you seeing the ISO violate these rules with exceptional dispatches that have been issued to date? And again, perhaps we could have an offline conversation about the specific details. But obviously, if you're bringing these up, it sounds like these are issues that are happening right now.
You know, we haven't seen them happen. The request is merely to have it, you know, formalized in the tariff. You know, so far from what we've seen, the reactions are what we've been told by, you know, CAISO. You know, so you know, we haven't seen it quite yet. We would just like for it to be formalized in the tariff.
Okay. All right. Okay. That's helpful. Okay. And then for the last bullet on this slide, when you mention that all resources should be paid loss opportunity costs, you know, I certainly would note that exceptional dispatch and specifically exceptional dispatch for storage resources, where we are going to tell storage resources in the future to hold and move to a particular state of charge, that kind of authority and the compensation around that are going to be addressed in this initiative. So it sounds like we're on the same page there. And I would assume that if we do get to a place where those exceptional dispatches are a tool that the ISO has to use, that would be including opportunity costs. But I was just wondering, have you thought at all about how opportunity costs should be valued and how it should be compensated if the ISO does issue those kinds of exceptional dispatches?
Yeah, we have, and we definitely enjoy a conversation offline. We can speak to that in a little bit more detail with Kathleen and the rest of our team to kind of go over our thoughts on how that should be formulated.
Okay. Yeah, I mean, the reason I ask is a lot of what we're using here from these slides, transitioning from the ISO's issue paper to a straw proposal, is going to be a formal proposal of what we would like to see in functionality going forward. So having those thoughts, and maybe that could even be something that's included in your comments on this, you know, today's presentation, could be helpful in informing that straw proposal.
Sure, that shouldn't be a problem.
Yep. Okay, great. So maybe, Jimmy, I might have had a question on the next slide as well. And again, these are very high-level questions because we just don't have time to get into every detail here. Jimmy, could you advance to slide 8? Perfect, thank you. Oh, yes. Yeah, I think when we are talking about nature of work and how all those work, it's likely that, well, and the questions related to OMS. I know from firsthand experience that the way OMS works today and the way that the data is stored from OMS on our end is very complicated and frankly, probably more complicated than it needs to be. I know for certain that in the Resource Adequacy Enhancements Initiative. They're working on improvements that could potentially be made to OMS to, I think, first and foremost, make access to the outage data more straightforward on the back end. So for ISO purposes, we should be able to review and analyze this data a lot easier. But on the front end, I think we're also looking to make some improvements. So to the extent that, the OMS type improvements are relevant here, even specifically for storage resources, I think talking about it in that stakeholder initiative could be worthwhile because we are planning to already open up that tool in that initiative. Here, I am a little bit reluctant to open up or do a lot of OMS work because OMS can be difficult and it can be a very challenging thing to make changes to, but I'm not going to expressly rule it out, and I think, clarifying things about nature of work could be something that's in scope of this project. We haven't really given too much thought about this to date, but I think you bring up some really interesting points here. And again, I think perhaps some additional color on how some of these issues are coming up and, what would be helpful about the clarification could help us move that conversation forward. But I don't think I'm necessarily against anything that you have here on this slide. A final thought, and I think this is just more of a general comment on timelines. Typically, stakeholder process for the ISO does take several months to complete. It involves, like we talked about at the beginning of this slide deck, putting together issue papers, putting together straw proposals, and a whole series of straw proposals and getting feedback on those, getting stakeholder input, and realistically, getting anything through the stakeholder process that's beginning right about now, like this one, and moving forward in time, it would be very difficult to complete any stakeholder process before middle of the year 2022, and then once we file at FERC and once we start to do software development, oftentimes actual implementation for solutions won't be in place until perhaps end of year 2022 or maybe even beginning of year 2023 if things go well in the software development range. So that's sort of, I know you sort of put together some timelines on when you'd like to see some solutions, but realistically, I don't think we should actually be anticipating any solutions prior to fall 2022. I think staggering implementation after that point is certainly a possibility, but I think hopefully I'm sort of in your camp is let's try to get as much done in fall 2022 as we can if these items would be helpful for the storage community, and then going forward from there, if there's some deeper problems or more holistic market changes that need to happen, maybe we think about that on a longer timeline. Which isn't to say I don't appreciate the work that you put together here, and I certainly do appreciate you sort of prioritizing when you might like to see some of these solutions in the market. That's helpful for us to just kind of understand sort of the complexity that you guys view some of these issues at and kind of the importance of when you'd like to get those done. So I do appreciate that as well.
Sure, no,
at that
I appreciate
point,
that.
I know we have a couple minutes. Oh, yeah. I know we have a couple more minutes. If there's anybody else from the ISO with questions or comments, now would be a good time. And I heard somebody there.
All right, hearing none and not seeing any questions in the queue or the chat, I just want to reiterate Gabe's appreciation, Brad. Great input, as well as
thank you for the feedback
thus far. Yeah, you do have additional time, a few more minutes, so appreciate your timeliness if you want to add any more thoughts before we move on to the next presenter.
Hey, this is Arnie Quinn.
Yep.
Yeah, I just want to kind of follow up on that last point about kind of timing and kind of what we should be realistic about. I just want to make sure that the point that we're making is clear, and that, I think I know our view and our suggestion is some of the things that Brad's talked through today are really near-term day-to-day things. And so our suggestion to the ISO is, maybe take this initial feedback from all of the presentations today and do some triaging, and some of these more day-to-day kind of very operational elements, which make kind of the ISO operators' lives harder, make the battery owners and operators' lives harder, maybe carve them out and allow those to move forward on a faster track, and not delay them while the ISO addresses some of the longer and medium-term enhancements. So I just want to make sure that part of our suggestion was clear.
No, I think that's helpful, Arnie, and I appreciate the additional color there. And I think you're right too. There are some things that the ISO can usually handle in a very short period of time. Sort of things like BPM clarifications, and I'm having a side conversation right now with some of my operations folks. I think there might actually be a process to update some of those nature works right now. I don't have the details on that for exactly what's happening, but I certainly will next time we talk. But I was more referring to the kinds of things that require updates to tariff. Those tend to be a lot slower process. And even when we do fast track things, it still can be several months before we see actual implementation of solutions. But I think your point about addressing some things faster is well taken. So I appreciate that.
Thank you.
Yep.
All right. Well, thanks once more. And then
maybe we should move on to the next slide deck.
Yeah, we have Susan Schneider. Susan, are you on? If you're going to do an audio check, I transition the slides.
Okay, I'm here. Can you hear me now?
Yes.
Hello?
How are you doing, Susan?
Okay, great. Thank you. Okay, can we put the presentation up? Or are you switching? There we go. Okay. Anyway, very much appreciate the ability to talk today. We're going to, what I would characterize what we're talking about today is as, in some ways, cleanup issues. I did want to echo Carrie Bentley's request for additional data. There are several times in recent stakeholder initiatives where we said, well, how often does that happen? Or how often do you think that might happen? Or, those kind of things. And it would be helpful to have those feelings rather than, well, we think it won't be very often. Those sort of things are, I think, helpful if there's any kind of quantification and backup data that can be provided. I also want to say, just as a process issue, there have been a couple of recent stakeholder processes where normally what the CAISO has done, and I know it is laborious and time consuming, but to go through each of the points and all the comments that you get and explain, and particularly if you're not going to incorporate them in the initiatives going forward, to say that and explain why, because there have been a few times where basically the comments were not mentioned in the next version of whatever proposal it was, and it's impossible to know were those comments read, were they not read. You end up having to repeat yourself because you're not really sure if anybody really looked at it, and it would just be helpful if in this initiative and other more recent initiatives, if you could sort of reinstate that practice. So anyway, let's go forward. Okay. There are three issues we're going to talk about. Most of what we're going to talk about today is the first issue, and our position here is mainly that these particular issues should be in scope. So for the first one in particular, we don't necessarily have definitive answers. We have some feelings about things, but we don't have necessarily answers. And the last two, or the middle one we do, and the last one we're asking for clarification. So mostly this proposal is going to talk about grid charging issues and the ITC. So I know that was mentioned this morning. This is a huge issue, and with Large Scale Solar Association, right? Not storage, but most of the members are developing mixed fuel resource projects, and there is a great concern about, in particular, for the co-located resource configuration, where you've got a separate resource ID for the storage and, in most cases, the solar. and how the ITC can be maintained going through the actual market operations. So we feel the CAISO said earlier, well, I'm going to go through this in a minute, but anyway, we want to focus on that issue mainly today and talk about the kinds of tools to manage grid charging that may be available, but we're not really sure, but that maybe could and should be available in the future and should be considered in this initiative. So let's move to the next slide. Okay. We have felt, and we stated this in the Hybrid Resources Initiative, the ITC is a federal policy, and the CAISO had come out, well, I'm going to talk about what the CAISO said in a minute, but this is a federal policy, just like, renewables promotion generally, tax credits, other things. And the CAISO rules should support compliance and most certainly should not frustrate compliance with this. So it's not something the CAISO should ignore, and in fact, the CAISO should help facilitate it. And in particular, market participants are starting to do things that the CAISO probably does not want them to do. And in a couple cases have said, well, we prefer that you not do these things, but may not have any authority to keep them from doing them. And in the long run, they're not helpful things for the market. So what we would like to do here is to clarify the tools that are available for grid charging and then hope that the CAISO will include in scope for this initiative some additional tools that could help manage the grid charging and the ITC maintenance. Let's go to the next one. Okay, I think most people know this, but just to put everyone on the same page, the ITC is absolutely critical for economic storage financing today. And in fact, the lowering of costs through the ITC is lowering the cost to ratepayers because those are usually reflected in bids that for building these resources. It covers up to 30% of capital costs, but full credit for the ITC requires that 100% renewables charging occur for the storage facility. So even though the grid energy, in many cases, we see that on the postings on the CAISO website that a good part of the grid energy may in fact be provided by renewables, that does not count in the 100% renewables. And so basically the practical way to do this is to co-locate the resources or put them together in a mixed fuel resource. There's 1% of ITC lost for each 1% of grid charging up to 25%. This is an annual kind of calculation, which we'll talk about in a minute. And if there's this big cliff after 25%, so 25.1% means that the entire ITC is lost. And that is a huge threshold and a huge economic hit to any project. Let's move on. The next slide. There. Thank you. Okay. When you're talking about co-located resources, the common interpretation is for tax purposes that, of course, you're talking about two separate resource IDs, but you have to be able to generate and each resource ID basically is billed and scheduled and settled as though it was a totally separate resource so that, for storage, it's, output going to the grid and energy coming from the grid, and for the solar or variable resource, it's just output going to the grid, even though electrically the electrons flow back and forth. So the interpretation here is that it is okay, and you can demonstrate for tax purposes that the solar is, or the variable resource is going to the storage. If on a 5-minute basis, if the storage is charging, then the charging volume is below the variable resource output. So on a 5-minute basis. But there's a couple of complicating factors here. First of all, the ITC compliance may be a financing condition. So it may be that a resource that charges from the grid in any material way will be violating its financing conditions. So this is really, really critical and really must be adhered to by any of these resources. The tax benefits sometimes are sold in advance. So there are investors in projects, and I know most of you probably know this, but there are investors in projects that mainly are investing for purposes of the tax benefits. And sometimes the tax benefits may have been sold in advance. So it's not something that you can decide to impair on or would be able to inadvertently even impair in any material way. Property, it's not just ITC that we're talking about here. Property taxes are also a factor. There's property tax exemptions in various places, and those projects that that qualify from the grid that charge from the grid do not qualify for these exemptions. And the other complicating factor here is this is an annual calculation. So for any particular market bid, it's hard to know whether you're going to go over that 25% threshold for the ITC, for example, without knowing what will happen the rest of the year. So it's a little bit, it makes this all very complicated and difficult to figure out. Let's go to slide 6. Okay, well, and the CAISO has been a little bit sometimes accommodating and sometimes not. There was a technical bulletin that was issued in 2016, which I know most of you have probably seen, and it did have discussions in there about projects with multiple resource IDs. We didn't, of course, have the more advanced terminology that we have now, but there was a project with multiple resource IDs, and under that category were options, basically statements that they had all options and that they could have an option of charging from on-site generation only. And there's a table in there that says that, which is also sort of imported into the Hybrid Resource Initiative revised straw proposal. So this is the implication here is that you can limit grid charging with multiple resource IDs and have it charge only from on-site generation. Now, the straw proposal and into the revised straw proposal for the Hybrid Resources Initiative also, though, had a statement which was sort of the other direction, which is, well, there are well, I mean, this is not quite the other direction, but basically there's a qualification here saying, well, you can do charging from on-site generation only, but you have to have you can put a limiting scheme in place, or you must, in this case, you must have a limiting scheme. So that's pretty much consistent, which basically says, well, where you can have multiple resource IDs and charge only from on-site generation, and you can use a limiting scheme of some kind to prevent this. So let's go to slide 7. Okay. However, there was in the revised straw proposal, there was a statement that basically said, well, we know this is a business driver, we know this is important to you, but this has to do with taxes, and this is not our problem. This is your problem, basically. This is an out-of-market incentive, and it's not something that we are going to that we are inclined to fashion market rules to accommodate. So there's that issue. And then the later proposals dropped any mention of any limiting scheme or any ability to limit charging from the grid. So we were sort of left with these mixed messages where the early input looked promising, the later input not so much, and then there was any mention of any help in this area just was sort of dropped from the entire thing. So in addition, there were some statements at CAISO stakeholder meetings where people were asking, well, can we put say limitations in the master file that said you can't charge from the grid? Is there something we can do with that? And statements from the CAISO indicated that the master file could only reflect physical limitations. And if you were going to do some kind of limiting scheme, say through software, that's something that the master file would not necessarily be able to accommodate. Same with anything you're doing with contracts, financial, any of that, the master file only can reflect physical limitations and not software issues. And so that sort of left people wondering, well, what am I supposed to do with that? So let's go to the next page. Okay, so I want to talk a little bit about tools that we know are available, tools that statements have been very vague and may perhaps be available, but there's been a lot of side conversations and we're not really sure what is happening for the reasons that because this situation is not clear, and some additional tools that should at least be considered. So let's go to the next slide. Okay. We do know that there are some tools that are available. For example, if you've got a solar and a storage resource ID, both resources have a must-offer obligation based on their particular technology. And the bids, you can structure the bids so that the storage resource ID for charging schedules and dispatch is less than the variable resource ID. But since you have to offer everything on the storage that you have and everything that's forecasted on the variable resource, you have to do this through basically offering different bid segments. So hoping that, in times like, for example, if your storage in the resource production ranges for your variable resource that you're very sure will happen, you can make sure that your storage is basically priced to charge during those times. But it gets a little bit dicey when you start getting into the, you get to the P50 var forecast or the P75 or the, the P25 and the less probable ranges for the variable resource, and then your storage bid prices have to reflect that. So you can try and coordinate your bid segments and your prices for the two resource IDs to make it less likely that your storage is going to be charging when your variable resource is not producing. But it's a very difficult thing to do. And even if you manage to do that in your scheduling, so you have a charging schedule for your storage that is not any more than the output of your variable resource, well, things can still happen in real time. For example, the generation may be producing less in real time than scheduled. So now your storage it must still follow your dispatch instruction. So you may have to continue charging even though your variable resource is not producing enough to support that. You can try and go into if you know that it's a bad solar day, you can go into the real-time markets and try to bid your storage so that you're trying to sort of back off of the storage charging at times with the variable resource, but that is a blunt instrument and really difficult actually to do. So let's go to slide 10. Okay, so things that, and again, the ISO has made some statements saying yes, some statements saying no, so we're not really sure what is going on here, but it is possible that storage charging could be subject to software limiting schemes. So that basically that the POI that is shared will not be importing any energy when that is basically that will go at all, so that will go to the storage. And again, there's some mention in the early documents that says this might be allowed, but then we don't know. It's not in the later documents, and it's not really clear. It's possible to set the master file in some ways. Maybe this is allowed. We've had some indications, for example, that the storage co-located resource PMIN could be set at 0, which would technically disallow the negative range of storage. But first of all, if the storage is being counted as flexible capacity, of course, it has to bid the entire plus and minus range. So it's not clear what that means. And if you have a PMIN of 0 for a resource ID, does that mean you can't even charge at all? So we're not really sure if this is a viable strategy or how this would even work, but we have some indications that perhaps this could happen. The aggregate capability constraint that was implemented last fall perhaps could be used to do this, where the storage could be set at its full bidding, the PMIN for the storage could be set at its negative limit, but the aggregate capability constraint would be set with a 0 minimum. So what that would mean then is these, at least on a scheduling basis and also on a dispatch basis, there wouldn't be any energy drawn in from the grid or imported from the grid. Again, we don't know if this would really work, but we think it's possible that it would, and we would like to know if that's true and if it would be allowed. So let's go on to the next slide. Okay. So what's happening right now, and this is all happening kind of, the CAISO I think is maybe peripherally aware of some of these things, but in terms of what's going on just in terms of charging and scheduling for charging, the strategies people are looking at is being very, very conservative. Basically, sizing your storage so that it's unlikely that you'll be charging more than what your variable resource will produce, or executing. So there are many PPAs that actually prohibit grid charging. Now, how that would happen and how they would do that, it's usually not specified, but many, many PPAs have been executed that actually prohibit grid charging, at least in the first 5 years. And there are various other things that people are thinking of doing. For example, physically disabling, putting in a switch or something that prevents them physically from charging from the grid. Because going back to this, well, the master file can only reflect physical things. Well, then maybe you just disable your own project, basically, so you're not physically able to charge from the grid. That's obviously not optimal. And even if the CAISO is in a system emergency, for example, even if it's not being bid that way, the CAISO might want to be able to charge up a resource so it could be ready and when it's needed. But with physical disabling of the unit, that may not be able to happen. The other thing is, if it turns out to be really unmanageable to deal with this as co-located resources, that is the co-located resource configuration. The CAISO is very clear up front that that's what they want. That's how they would like these mixed fuel resources to be configured. But hybrid resources, now this problem is not eliminated with hybrid resources, but they have a lot more flexibility. And so you may see some people who start out, or some projects starting out as co-located resources, and if this turns out to be not manageable, you may have a lot of conversion to hybrid resource configuration. And the CAISO has always said that is less preferred. So that may happen if there's no other way to manage this. Let's go on to the next slide. Okay. So some things that could happen, again, these are examples. These are not, we don't not have the magic bullet here, but we do want, all the smart people that participate in these stakeholder processes and work at the ISO to help to really focus on this issue and see if we can come up with some ways where this could be managed in a way that will still make the CAISO comfortable reliability-wise. So one of them is, could you please clarify whether all those master file entries described above are allowed? Is there some way to manage this through the master file or the ACC, either way, which I think also goes into the master file? Is there some way to allow additional flexibility for storage for co-located resources? You've got a minimum state of charge that's already implemented, and I know we're looking at replacements here, but that does ensure that you've got availability for a storage state of charge for hourly schedules that will come later. So given that you have that protection in place, right now, if a variable resource goes above its schedule, it's allowed to produce that additional amount in real time, and storage can back off basically to make room for a co-located resource. But you can't go the other way. If the variable resource is producing less, then you can't reduce storage charging. Well, since you've got the minimum state of charge in place that will help ensure that you've got the state of charge for needing it later, maybe this could be relaxed, and maybe that thing could go the other direction. And if the variable resource output is less than schedule, then the storage could back off on its charging. There's also a prohibition on that particular flexibility item where the variable resource is producing more than schedule and the storage is allowed to back off. But it's not allowed for a reason that has never, I think, been adequately explained about why that can't happen when the storage is providing ancillary services. Well, maybe that can be relaxed because you've got the minimum state of charge, you've got that level of protection, and maybe you could back off on that particular flexibility. There's been some discussion of supplemental compensation mechanisms if you've got lost ITC in some way from grid charging. Again, we're not proposing answers here necessarily for additional actions. We would just like to have the issues considered here in this stakeholder process. Okay, let's go on to the next one. Okay, this is an issue, and I think this was a real process problem with the hybrid resource initiative. There was no discussion of whether aggregate capability constraints would apply to pseudo-ties, and these would be pseudo-ties that are mixed fuel resources, and so they have storage and, again, usually solar. And they would, they have the same problem as mixed fuel resources physically inside the CAISO. They are within the CAISO's balancing authority area, but they have the same market participation problems as domestic resources, where they have the master file issue, and they have to need the ACC in order to share their interconnection capacity. Now, there's an additional level of complication here where they have to get firm transmission requirements, but we don't see that this is an issue. But anyway, what happened is this is not discussed in the Hybrid Resources Initiative, but in the cover note to the FERC filing for that, I think it was the first phase, I don't remember if it's first or second phase, first phase, I think, there was a statement that said that pseudo ties could not take advantage of ACCs. They wouldn't qualify, even though EIM resources would qualify. We don't really understand why that wouldn't happen. We think that any concern about firm transmission rights can be accommodated here. We don't really actually see that it's an issue at all, because you still need firm transmission rights for whatever comes out of this resource. And so whether it's constrained by an ACC or not, you'd still need it. So we think it's completely compatible with ACC, and we'd like to see that prohibition relaxed in this initiative. So I've got one more slide here, I think. Let's go on to the next one. I'm not going to go through all of these in detail. You can read them, but there's some weird I feel like I'm sorry. I probably should call them something more diplomatic, but there's some weird statements in some of the documents for the Hybrid Resources Initiative that were really not explained, and we would like the CAISO to just go through and clarify and explain these resources. So anyway, that's really all I can say about that. Okay, that's all I've got for presentation. I think we've got some time for questions.
Hey, Susan. Thank you so much for this presentation, Ms. Gabe. Jimmy, could we potentially move back to slide 10? I did, and again, I think similar to the other discussions that we've had today, I have some deeper questions, but I think I'll ask some higher level questions right now, and perhaps we have some offline conversations. And I know you and I have talked about some of these topics already, but I think we can continue our dialogue into the next phase of this initiative. Mm-hmm. So I did want to specifically address sort of the ideas that you had here on this slide. I tend to agree with you. I think the proposals that we had did evolve over the Hybrid Resources Initiative, and I agree. Initially, we were thinking about I think what you call software limiting schemes, or I think rather what we called software limiting schemes early on in the initiative. But as you pointed out, you are correct that got dropped in later versions of the paper. So, I think you're right. Today, we certainly do not have any software limiting schemes for hybrid resources or co-located resources to sort of prevent them from, quote unquote, grid charging during certain times. Well,
it doesn't say that they're prohibited. It just doesn't say that they're allowed, and so it sort of leaves the whole thing unclear.
Right, and I think the point is, we didn't include this as part of we didn't develop any software limiting schemes in the Hybrid Resources Initiative to be used for this purpose, and therefore there aren't any today. And that's sort of what I'm getting at.
Well, I think I think you're raising an interesting point, Gabe, which when we looked at soft limiting schemes, we were assuming that those would belong to the interconnection customer. So I think, but from what you're saying, you were thinking about limiting schemes that the CAISO could have, and I think I could go out either way. And so I think but I think we can leave that open to discuss whether if you're going to allow them, which entity and should have them and how should they work. So I think that's a really interesting question.
Okay. Yeah. Oh, and I think the first thing I wanted to address is, I appreciate you bringing up ITC credits. We will certainly include that in scope with this paper, so I can confirm and promise to you that this will be included in our straw proposal. And similarly, I'm also reasonably confident that we'll be able to include pseudo ties for those resources, allowing them to use ACC as well. So I think we can definitely accommodate these two in this initiative. Just getting back to this page, though, I think you are correct. We did, the ISO did have some early conversations with some market participants about potentially, quote unquote, disabling charging for storage resources, particularly co-located storage resources, by setting the PMIN to 0. I think your second sub-bullet, the yellow bullet here, is absolutely correct.
Okay, I thought it might be the case.
yeah, you can't actually charge the resource, and it doesn't work with the model that we have in place.
Right.
So I think since we've given advice or kind of had that as a thought, we've walked that back and said, no, if you do in fact have a P-min of equal to zero, our model isn't able to charge the resource, and then we get into some real problems.
Right. Okay.
So unfortunately, even if we wanted this to be a solution, it really isn't today.
Right.
I actually hadn't thought much about using the ACC as a means to do this. I think as you and I have talked about, and as you point out in this presentation, I think the ISO's real objective is to get as many bids in the market as possible, including charging bids and discharging bids. That way we can, supply energy at the least cost to customers. And I think our preferred approach would not necessarily be to limit resources from the ability to discharge, but rather to have some sort of a, as you suggest, compensation mechanism if we do inadvertently dispatch the resource to charge while, like you say, it's a bad storage day and you just don't have very much coming off of your solar panels. So to that end, I think I'd be willing to at least start to think about and start having a discussion about what an alternate compensation mechanism for that sort of thing might be. So then we could hopefully get something built into the market where these resources could bid in, but then if they were inadvertently dispatched to charge and it was a grid charge, that they could get the compensation that they need to cover their ITC costs. We certainly don't want to prevent them from being developed or something like that because they don't think they can get this ITC, which they need to be competitive.
Okay, well, give some thought to this last one on using the ACC as well, because we don't have any set position, at least not within LSA and SEIA on these issues. We just would really like the options to be looked at. So I really appreciate what you're saying about it and look forward to working with you on these things.
Great. Thanks, Susan. Very nice presentation. I do appreciate the feedback. Anybody else on the line from the ISO with questions or comments? Okay. Jimmy, maybe we can move on to the next slide deck.
Great. Thanks so much, Susan. And I do reiterate, Gabe, appreciate where I was looking for ways to improve our stakeholder process. So thanks for all that. We do have LS Power next. I want to make sure that Renee is on the line. Do an audio check as I transition the slides.
Can you hear me?
Okay, great. Yes, great. Hey, Renee.
Great. And I'm joined here by my colleagues, Andrew Nowicki and Brian Bartholomew, if we can get them as panelists as well.
Okay, great. Thanks. Yeah, Adam, if you wouldn't mind, if you're able to promote them.
And great. I see them now.
Thank you.
All right. Yeah, so I'm Renee Steichen, Director of Regulatory Affairs for LS in our Western California office. And Andrew and Brian on with me are in charge of our day-to-day operations, leading our storage assets here. So we have been, operating storage in the CAISO market since 2018 and, brought our second storage online last August. So we have spent the last 3 years, and particularly the last year with a larger resource, kind of cutting our teeth on the CAISO market. And, we're very thankful to CAISO for having this initiative and having us present today, and particularly for, showing the foresight to have this. I know it wasn't originally on the schedule to have this initiative at this point, so we're very thankful to be starting to address these issues as I think more storage assets are going to be experiencing them. And, we want to be good market participants. We want to be available and meeting our contractual obligations and reliability needs of the grid. And the main tool that we have available for that is our bid curve. And so a lot of our proposals and recommendations today are kind of around being able to rely on the bid curve for dispatch. And given that we have these obligations that we need to meet. And so anything that kind of influences our ability to not meet our bid curve is a big challenge for us as a market operators. So if we can go to the next slide, please. I do have our comments, a link to our comments there. So a lot of our comments today are going to be kind of pulling from what we submitted as our issue paper comments. One thing I don't have here is, we also proposed a phased approach, kind of focusing on these more day-to-day operational issues, and then something like a minimum state of charge replacement as a kind of a second phase, or other issues that have been brought up today. It's been a lot of great ideas and discussion, so hopeful for some good solutions moving forward. But the four we're going to cover today are primarily on multi-interval optimization, so kind of being able to ensure efficient and reliable dispatch, and then bid cost recovery, and that's going to be kind of a common theme throughout all of our proposals here. And given the financial implications of not being able to kind of rely on our bid curve and being dispatched outside of our bid curve, it definitely results in financial negative impacts for us. And then exceptional dispatch, and then the variable charging rates. Next slide. So with multi-interval optimization, we have experienced this as, the effect is that storage resources are not strictly dispatched according to our bids or to the binding energy prices. And we think multi-interval optimization makes sense for the market, particularly for traditional generators, the way it's been operating, in more historically, needing to prime the resources and make sure that they're going to be available for when you actually need them, so they have that look ahead at these advisory prices. But for a resource like storage that is able to be, extremely flexible and respond immediately, these advisory prices and looking ahead with the MIO result in being dispatched kind of outside of our bid curve, which then leads to other challenges. So particularly, a few examples of things that concern us as a result of the MIO is that if resources are discharged early, prior to the evening peak, where otherwise our bid curve was designed as a way to preserve the state of charge and enable delivery of our day-ahead energy awards, if MIO dispatches us prior to that peak, then obviously we're not going to be as available. Another issue is if they're not discharged when energy is needed most. For example, if there's very high prices and the advisory period sees even higher prices or more optimal time for the market for storage to dispatch, but those prices may or may not actually materialize, and so in the meantime the storage resource is withheld and not able to kind of respond to the market to these price signals. And sometimes these situations result in a reliance on out-of-market measures such as exceptional dispatch. Next slide. And here's just a typical example that we have here. This is a real-life example of something that happened, and we have so in this instance, our bid curve was such that we'll charge at anything below $50 a megawatt hour and discharge anything above $100 a megawatt hour. But you can see here that we were dispatched outside of that bid curve, where we were discharged at $36 and then shortly after recharged at $37 and then discharged again at $25. So nowhere kind of near our bid curve, but potentially MIO saw something in the future that was trying to prime the storage resource to be able to meet it, but never ended up appearing. Next slide. so then the result is that, you know, the MIO kind of locked in the financial losses for that binding period. And, you know, without being able to see those advisory prices, we don't know what was predicted to happen. But, you know, we also see that MIO tends to perform poorly, in particular when system conditions are tight, and that kind of creates more market volatility naturally, but that makes the advisory prices even less accurate. And, you know, the kicker with all of this is often that bid cost recovery does not kick in because it looks over, you know, as we'll get into a bit later, but because it's looking over the entire day, these types of what are, you know, potentially small but also potentially large losses as a result of these inefficient dispatches can really lock in big losses for the resource. Next slide, please. And closely related to MIO as we see it is spread bidding. You know, spread bidding happens kind of as we are interpreting it anyway, it kind of implicitly with MIO. It's kind of looking at the spread and the advisory to see if there is a more optimal time. Additionally, there was also a recommendation or an idea in the issue paper to implement spread bidding more explicitly. And we see some challenges with this, particularly because if it's a spread, you know, that might be okay for some instances, but it can disregard the actual resource cost. If you have a big curve of charging under $50 and discharging over $150, you know, that's a $100 spread, but that $100 spread is very different at $50 and $100 versus $500 and $600 megawatt hour. You know, the spread is the same, but really the bid curve is trying to keep that resource charged to be able to meet the, you know, potentially the evening peak, for example. But if it's just using the spread, then it's not going to see that signal that we're trying to send. And as a result, that can lead to, you know, reliability and financial risk for the resources, particularly if it has a day-ahead obligation or other contractual obligations. And, you know, similar to MIO, the implementation of spread bidding right now, you know, we understand, according to our understanding, you know, it's not specifically happening right now, but, you know, this type of behavior tends to kick in with no warning to market participants. So we don't know what's happening because the advisory prices are not published. Next. So that leads to some of our recommendations on this, on MIO and spread bidding. Particularly, you know, I think our top recommendation is that storage can, you know, in a sense, opt out of MIO because it doesn't need to have any sort of prep time to be available for storage or for the market if we're only dispatched according to the binding price interval, which would be in according to our bid curve, and where we're trying to send those signals versus, you know, looking ahead to our next hour bid curve, for example, where we are maybe sending different signals of trying to be charged or discharged. So if it's only on the binding price interval, that is our kind of our top recommendation. If we can't opt out of it completely, then potentially fewer intervals, such as 2 or 3. So it's not seeing quite as far of a look ahead there. And, you know, we're hoping that this would reduce some of that, you know, as we see it like phantom arbitrage. And if spread bidding is implemented, then we would prefer to be have the option to opt out of spread bidding because of the issues that I mentioned earlier. Apologies for the bell. Then also for the bid cost recovery, you know, as I mentioned, this is going to be a theme throughout all of our recommendations here, but, you know, providing bid cost recovery for MIO and locking in some of these losses, getting recovered for that would make it better for the resource to be able to you know, kind of reduce the wear and tear costs and, you know, potentially not meeting contractual obligations. And as others have said before, publishing the advisory prices would be helpful. Understanding that it's a massive amount of data, but that other markets have done it, and so being able to see some of those prices would at least allow us to be able to be better informed about what the market is seeing, whether it's actually MIO or something else that's happening, and then being able to kind of incorporate that into our models to be able to update our bid curves. And the last item here, we don't, this is maybe an unpopular opinion among the stakeholders, but we don't think that extending the real-time market lookout horizon is desirable, even if it was feasible, particularly because of the problems that we see with MIO and that it's kind of creating this uncertainty. And so if you're extending it even further, then that could potentially have even more uncertainty. Next. So for bid cost recovery, some of the challenges is that because it compensates NGRs for net revenue and losses for an entire day, it's such a long time horizon, and at such a gross scale, it's very difficult for storage to ever get BCR. And if you've even gotten like $100, even though you were supposed to get $10,000, because you made some money that day, BCR will not kick in, even though you have, if it was according to your bid curve or without these, potential issues, then it could have made a much more revenue that day, which is needed to cover our operational costs, if nothing else. So we think that BCR needs to be rewritten in a way that accounts for some of the specific characteristics of storage. For example, there's no compensation when for the opportunity costs when NGRs are exceptionally dispatched down. And I heard Gabe mention that that specific issue is going to be covered in this initiative, so we're thankful of that. And, also from our understanding, BCR does not recognize that a full battery can't charge. So, it's seeing that willingness to charge according to the price. Even if we're full, if we could have charged, then anything, kind of below that is seen as a revenue in BCR. Next. So one of our recommendations here is to compensate the resources based on the settlements that would have resulted if the actual bid curve was followed. And this could kind of undo any financial harm that MIO or exceptional dispatch or whatever other tool, out-of-market tool is creating these dispatches outside of our bid curve. Alternatively, you could compensate based on the volumes and prices by which the bids were not followed in each interval. And some of the ideas in the issue paper, mentioned, potentially compensating over a shorter time horizon, such as 8-hour window, or based on some sort of cycle spread. And, we think that could work, but could be very challenging, especially for different types of storage resources with different durations, and defining what that specific time period or cycle would be could be very challenging, especially across all resources. Next. Next, please. Next is on exceptional dispatch. So we find that CAISO, again on the BCR, doesn't compensate storage for exceptional dispatch when it's removed from the market. And so we've had some instances, for example, where exceptional dispatch has kind of disrupted or, prevented our resource from delivering day-ahead awards, sometimes if not for having that conversation directly with CAISO, mentioning that we have a day-ahead award. And, sometimes the BCR methodology, because we made some money that day, again, it doesn't kick in for that, even though it potentially held the resource or operated outside of the bid curve for a time period. So some of our recommendations here are to implement an NGR-specific bid cost recovery so that the resources are compensated for these exceptional dispatches. Again, it sounds like that is going to happen, so that would be extremely helpful. And then, we're hoping that CAISO operators could have a view into what the resources day ahead schedule is, and that could help, align any sort of exceptional dispatches with the day ahead schedule to improve reliability on the system. And there was an idea in the issue paper to target a megawatt hour versus a total megawatt amount, and we think that could also help avoid unnecessary discharges. And in that slide, it says in the example to the left, but it's actually the next slide. So if we can go to the next one, we're going to go through an example here. So this was an actual example from a couple weeks ago of an exceptional dispatch that we received. And so you can see the resource discharged and then immediately started charging again in hour 16. That arrow is wrong, unfortunately. It should be over at the end of hour 16. So the resource was charging during hour 16, and then, if you look at the bottom part there, where an exceptional dispatch kicked in and at the end of hour 16, and the resource was actually dispatched, and then goes through this cycle of being charged and discharged during exceptional dispatch time period, when the resource was actually kind of on track to be fully charged, ready for the evening peak, but in the exceptional dispatch situation here, ended up charging during some of the highest price periods of the day. And, in this example here, we did not receive any bid cost recovery for that exceptional dispatch. Next. The last one I'll go over quickly, but we did, because it was covered, I lost my slides. Yeah, if you can go over the previous slide, please. Thank you. So, no problem. Vistra covered this as well, but, with the issue of using the state of charge to limit infeasible dispatches for the variable charging rates, battery storage in particular has kind of a known limitation on charging. We see it with our cell phones where that last couple of percent takes much longer to charge. And so we can, given that this is a known constraint, we're hopeful that there's some easy solutions that CAISO can implement. A few of our recommendations here. One is to potentially implement a real-time state of charge and AGC telemetry in the real-time dispatch. To be able to add those constraints in there. Or we can allow storage operators to submit kind of a piecewise megawatt versus state of charge into the master file to be able to accommodate that function. And if you go to the last slide here, next one. And that's just a chart showing an example of how that happens, for the first 80+%, almost 90%, it can charge at a very high rate and a constant rate, but then that last 10 to 12% in particular just takes much longer to charge. And I think one thing I forgot to mention on the last slide is that one of the ideas in the issue paper was to potentially oversize storage units to compensate for this so that it can charge at a constant rate. But, we would highly recommend against that because of the excess costs that would cause for the storage resource and then therefore to the ratepayers in California. And that would just result in a lot of oversizing and unused capacity that's going to be on the grid. So we think because it's a known constraint that it can be accommodated in the master file. And I'm going to address a chat question before I have them open it to other questions here is on from Mike Castellano asking what other contractual obligations LS Power has on storage resources. So in particular, I'm thinking of, as an example, is energy hedges that we have with LSEs to, and I know this is similar to what's covered in the CPUC RA proceeding. They're talking about energy hedges, but a lot of LSEs already enter into that. So we have, contracts, for example, to buy energy at a certain price during a certain time and discharge at a certain time. And so these are, another example of some obligations that we have. That's it for me, so I'll open to other questions that either myself or Andrew or Brian can answer.
Hey, Renee, thank you for that presentation. That was really nice. I did have a question. I know you're showing actually on this slide that's up right now that the resource's ability to charge declines as you get very close to full state of charge. We heard earlier today that this could also be a problem at the other end when the resource is almost fully depleted with discharging. Are you guys seeing that with your resources as well, or could that be something unique to the presenters that we heard earlier?
I believe we are seeing that, but it just doesn't happen as frequently. It's just much more frequent to happen when it's at trying to fill up completely.
Gotcha. Yeah, I could see that as well. Okay. So thinking about your comments on bid cost recovery, today, you're right, we look at bid cost recovery for a resource over a full 24-hour period. And if the resource is shown to be net revenue positive, then we wouldn't charge that resource, or we wouldn't award that resource bid cost recovery. But if they were net revenue negative, we would. Do you see changing these bid cost recovery rules as something that would be applicable to all resources and not just storage resources? Or is it just something that's really different about storage resources? And I'm sort of having trouble drawing if that's correct, I'm sort of having trouble drawing the delineation as to why that would be the case.
Hi, so this is Andrew. So basically the reason that we view that, well, I think the way that BCR is currently structured is for gas plants that don't have an unlimited energy capacity. And so when we because we go negative, unlike a normal traditional resource, we have a different sort of exposure to BCR, where that if a gas plant, for example, ran throughout the day and ran through perhaps unprofitable periods so that it could get to a profitable period later, its total baseline number that it gets paid for the day is sort of the area above in the graph that's always positive. But because we go negative and those negative periods could be very, very far out of the money due to exceptional dispatches or multi-interval optimization, that what happens is that we could actually find ourselves having made $1 throughout the day, and that would be a sort of a BCR win, where you made something for the day. But because we have those charging costs, it is unique to the storage resources. And if you're happy, I can follow up with you a little bit later to kind of outline that problem with a little bit more detail and maybe some examples.
Yeah, I might do that. I do think, as was noted in the presentation, which I appreciated, the ISO will be considering exceptional dispatch and how exceptional dispatches specifically for storage resources are compensated. And I think if we're going to have an additional conversation about BCR, we should be careful to say, what sort of issues fall under the exceptional dispatch bucket and what sort of issues fall under, general BCR for storage resources. But yeah, maybe let's have that conversation offline. And then hopefully, from that discussion, it can be informative about what we actually include in the first straw proposal when they put that out.
Yeah, that's a really good point. Those are two separate things. I think from our perspective, there would, in a day where there was no multi-interval optimization and no exceptional dispatch, for example, if every dispatch was in accordance with the binding prices in our bid curves, then there would never be a BCR event, basically, because our spread is fully captured. But we can go into that later. I just wanted to clarify that a little bit. Thank you.
I think that's useful to point out, and hopefully with whatever solution we come up with, whether it's approaching this from the BCR side or approaching it from the exceptional dispatch and MIO side, hopefully at the end of the day we come to a point where we're not having very many of these issues ever. Okay, I do want to leave a couple minutes if there's anybody else. Oh, the one other thing I wanted to note on this specific deck, I really do appreciate you guys including specific examples from actual operations from the resources that you manage. I think it's incredibly helpful to look at these, and it can be informative about the policy we may want to implement. I think this also speaks to some comments we heard earlier. Let's get some actual data and analyze some of these problems rather than sort of, maybe guessing what the problems are. So I do appreciate that, and I think the ISO will continue to look at examples like this to try to inform the policy as we go forward. At this point, though, I was going to check and see if there's anybody else on the panelist line who had questions for LS Power.
Thanks, Gabe, and thanks again, Renee and everybody. Not seeing any questions in the written chat. Operator, I'm not sure if we have any folks in the queue.
We do not have any folks in the queue at this time.
All right. And we are getting background noise. I just remind the presenters, anyone on the speaker line, please mute your line when not speaking. So. All right, as I transition slides, I believe we are coming up to our last but definitely not least presentation for the day from SDG&E. Stephen Johnson, just want to make sure, do an audio check. And Adam, if you don't see Stephen, I see Stephen's name. He might be double muted.
No, I'm unmuted now. Do I sound okay?
Okay, there you go. Yeah.
All right, great.
Thanks. There's your time once more, and here's the slides. Let me that big for you. And appreciate everyone's timeliness. So go ahead, Stephen.
All right, thank you. And I know I'm the last, so I'll either try to be short or at least entertaining. So I'm Stephen Johnston. I'm with San Diego Gas and Electric. I am the Advanced Clean Technology Innovation Manager. And for the last year and a half, I've been very focused on getting 2 hydrogen projects up and running down here. And the one that I want to talk about is the long-duration energy storage system that we're building out. And you can go to the next slide, please. For folks that aren't as familiar with SDG&E, we're down in San Diego. We cover the county plus a little bit, and one of our famous areas of our grid is Borrego Springs. It's a small town that's over the mountains and out in the desert, primarily surrounded by Anza Borrego Park, and it's unique in a lot of ways. They have a lot of light restrictions and noise restrictions and obviously environmental restrictions out there. But because of its remoteness, it in the past had suffered quite a bit from transmission related outages. And over the last 10, 15 years, SDG&E has built up a microgrid to support the system during those transmission outages. And another unique thing about Borrego Springs is that it is there's a 26 megawatt solar production farm nearby. There's a 6.5 megawatt commercial solar production, and then the town itself has over 5 megawatts of solar production. So there's just an absolute abundance of solar. And during SDG&E's last general rate case, we were approved to do a project on advanced energy storage by putting in storage where it would be in an area of our grid that has an abundance of solar. And so we're deploying 2 systems at Borrego Springs under that program. One is the hydrogen energy storage system, which I'll talk about further. And that is meant to be a long duration system. Long duration meaning it'll support over 8 hours of generation. And the second system is a more of a traditional battery energy storage system, which will primarily focus on the transition of grid operated to microgrid operated, so that that energy storage can pick up the entire load for a brief period of time to help with that transition to an islanding mode. And so the microgrid use case is the prioritized use case for this system to serve those local distribution needs. But because those needs are few and far between, maybe a few days a year, the goal is to use both systems in the CalISO markets in order to help generate revenues to lower the cost to ratepayers. So that's the bigger picture of what we're doing with this hydrogen-based energy storage system. You can go to the next slide, please. So for anyone that's not familiar with hydrogen, the main components here are a electrolyzer that takes in water and electricity, and the electrolyzer produces, or rather breaks up the water into hydrogen and oxygen. And then the fuel cell is the other component, which then, in this case, consumes the hydrogen, and the output of the fuel cell is electricity and water. And so it fits very nicely into the sort of sustainable goals that California has to sort of provide different type of and longer duration energy storage compared to maybe some other systems. The storage component of the system is effectively the empty metal cylinders or the hydrogen tanks that as the electrolyzer is producing hydrogen, compression pumps are used to pump that into the hydrogen tanks. And maybe as you might have seen at some industrial sites, they could be just standard hydrogen cylinders, or of course you can build larger metal storage to contain this. But the whole system is from, I think, in a simplistic way, from CalISO's view, the whole system is basically just electricity in, electricity out. So although it's using hydrogen as the storage medium, as far as the CalISO is concerned, it's really just a long duration energy storage system, although it does have characteristics which are what sort of we've termed asymmetric, which doesn't fit nicely into CalISO's current sort of operating model for energy storage, which I think lots of people have alluded to that all day long today. And so this is really just our first step into this. And one key part about this, although we're starting off this system to be a little, over 8 hours of energy storage to begin with, and let me just add a detail there. When I talk about an 8 hour of energy storage, we're basically saying that the hydrogen tanks are sized so that they can store enough hydrogen to run the fuel cell for 8 hours. So when we're talking about it being an 8 hour system, we're talking about the output of the fuel cell, which is the generator in this case. But the attractive thing about hydrogen is that if you most of the studies that are out there in the market point towards once you get past, certainly past the 4 hour period, 8 hour, when you get into the realm of days of energy storage, that's where hydrogen has the potential to become a more cost-effective solution compared to other technologies that are out there. And the site that we're looking at, again, although we're starting at over 8 hours, it is a desert, and so there's lots of unused land that SDG&E still has on the site. So the site could be expanded with additional cylinders in the future and potentially become a much longer duration energy storage system. But for the purposes of this project, under the current funding level, we're starting off at over the 8 hour mark. And you can go to the next slide, please. So when we talk about it being asymmetric, this is just one use case, sort of conceptual example of how the system could operate. And obviously nothing is to scale here. This is really just a conceptual picture. And also I should note that although the project is underway and we're marching forward under a schedule, it's got a lot of scrutiny from our executives. We have not selected the equipment yet, so because we don't have the exact equipment selected, we don't have the exact parameters here. So again, this is more just conceptual. But the idea is that the storage system itself will have pumps and other things that have to run potentially continuously. So there will always maybe be a little bit of an auxiliary load or station power and the like. But the idea is as the sun rises and the solar the distribution circuits out there start to have more and more solar, the electrolyzer could turn on at that point. And when the electrolyzer is running, that's your dispatchable load, but in energy storage terms, that's when the system would be charging. And the electrolyzer is let's say it's around 1 megawatt of load, and it would only need to run for about 6 hours in order to then fill up the hydrogen tanks to store enough hydrogen to run the fuel cell for 8 hours. So the electrolyzer in this example would be a 1 megawatt load for 6 hours. And then the system may turn off and store it for a while, maybe wait for the evening peak. Again, as we get into longer durations, maybe it would just, run all night, whatever the use case might be. But at some point in the afternoon, the system would then discharge. And by that, we mean the fuel cell would then start to consume the hydrogen and produce electricity. And as I mentioned, the storage is then designed to allow the fuel cell to run for 8 hours. So this is kind of roughly how the charging and discharging would look from a CALISO point of view. And we've already started discussions with CALISO to how to connect this to the CALISO system. So far, those conversations have led us to be looking at a hybrid energy storage, because at least the rules that are under discussion right now in the draft for the hybrid energy storage just allows a lot more flexibility in terms of how the system is scheduled. And because this is SDG&E's first electrolyzer and fuel cell system, we sort of appreciate that flexibility, because we don't really know the best way to run this. And it won't necessarily be run for optimum revenues from CALISO. It may be run simply to produce green hydrogen. So again, in the world of hydrogen, green hydrogen only counts as green if it's being produced by a renewable energy source, and in this case, all the solar out there. But if you're only running the electrolyzer while it's sunny out, you're not getting very good capacity or utilization of that asset, if you're only using it for maybe a third of the time. So there's also other scenarios where we may just run the electrolyzer nonstop if needing hydrogen is a different scenario. But again, this represents roughly, if we wanted to have a green hydrogen energy storage system, this is roughly how that would work. And the hybrid energy storage scenario right now just provides that flexibility for all the other unknown use cases that we have going forward. And the last point I would mention is that when we first started to talk to CalISO about this, it was SDG&E's initial preference to put the electrolyzer and the fuel cell in as separate resources, as two independent resources, because we felt that would give us the most, during this time right now where we don't really know how we're going to run it, it would give us the most flexibility, that we could run the electrolyzer, to optimize its characteristics. We could run the fuel cell to optimize its characteristics. But as we went down that path, we found that if we're looking at a 250 kW fuel cell, it does not meet the minimum requirement of a standalone generator for CalISO. The minimum requirement for a standalone generator is 500 kW, whereas for energy storage, it's 100 kW. So that seemed, it seemed an odd distinction. I'm sure there's good logic behind it, but from somebody who's coming in somewhat new towards putting a system like this into CalISO, I just find that a strange distinction, that the generation depends on whether it's energy storage or standalone generation. And there's ways to, if we were to say truck in hydrogen and that's how we were going to provide the hydrogen to the site, then effectively the fuel cell could run as a generator without that charging function. But there's other use cases where this becomes, it opens up kind of a lot of options in the future. So if you go to the next slide. And for those that are not familiar with hydrogen, there's a lot of discussion around hydrogen, specifically in California, but in Europe, in Japan, in a lot of other countries and regions that are really focused on getting to 100%, and actually getting to 100% clean, not just sort of talking about it. Hydrogen is seen as a really versatile technology for that future. Right now, hydrogen is used as an industrial gas in a few applications. And as I mentioned, that if one uses renewables to create the hydrogen, that's sort of called green hydrogen, and then it's seen as a clean energy source. And when you take that hydrogen and do something with it, then if you burn it for heating, or if you store it, or if you blend it with natural gas, or else you just power a hydrogen generator completely on its own, or put it through a fuel cell, again, all that is then considered a renewable energy storage or renewable generation. And so there's a lot of focus on hydrogen taking those hard to electrify sectors that can't be easily just run off of batteries or solar. And so the one, as we think maybe 2 or 3 steps beyond the current project, as I mentioned, there's land out there that SDG&E could create more longer duration hydrogen storage, but there's also scenarios where that hydrogen storage could be used in different ways. Perhaps that hydrogen could operate some heavy duty hydrogen vehicles out there. Either trucks for delivering things. There is a gas network. Perhaps the hydrogen could be used for blending into the gas system. So there's actually potentially other uses for the hydrogen, the green hydrogen that's produced out in Borrego Springs. And, who knows what the future holds, but it might also then require a way for SDG&E to track or, account for the hydrogen that's being put into the storage system for use in the fuel cell as that hydrogen energy storage, but then there may be a different amount of hydrogen produced that is not going to come back to the grid through the fuel cell, which then would just sort of be a traditional load. So these are just kind of some of the things that we're thinking about in that long-term vision as to how do we take a system like this and work with CalISO in a way that doesn't put unnecessary roadblocks or cut off any of these future scenarios. I mean, I realize that you can't build a system that is ultimately flexible, especially in kind of early days like this. But it, as much as possible, we'd like to work with CalISO and the other stakeholders on energy storage systems like this in order to provide for the most flexibility down the road as California is going towards this 100% goal. Let's go to the next slide. So that's the topic I wanted to talk about and sort of bring it up in this forum. My email's there if anyone wants to contact me afterwards, but I'm also happy to go through as many questions as folks have right now.
Thank you, Stephen. I appreciate taking the time to walk through that with us. And like you say, I think that does really tie in nicely with some of our earlier discussions about, thinking about what storage resources are going to look like in the future and maybe preemptively planning and modeling or updating how our models are going to work in order to accommodate those storage resources. With that, I don't know that I have a ton of extra questions, so maybe I'll just see if anybody else from the ISO has any questions. And if not, then we can go to the phones. The operator, do we have any comments on the phone line in the queue?
We do not at this time. Just a reminder that if you wish to ask a question, please select the raise hand icon located in the bottom right-hand corner of your screen next to the chat panel. And we do have someone in the queue.
Okay, great.
All right, Susan, your line's being unmuted. Please go ahead.
Okay. Hi, can you hear me?
We can hear you.
Okay, great. Anyway, I wasn't sure how this is all going to work. But as far as the green hydrogen, it seems like even though, so we're sort of back to the same thing we were talking about before with the ITC. Even though most of the energy on the grid at certain times is renewable, if you're not, it seems like this is more of a standalone kind of application. And so, do you feel like you could take the energy off the grid and still have it qualify as whatever green hydrogen is going to be? Or are you going to be using on-site generation, or how do you think that will work?
Yeah, it's been an interesting discussion in the company here. The section of the grid here has an overabundance of solar. Almost to the point where it's a third of the time that there's so much solar out in this town. Because again, it is a very small town, so. And although some of it is at the transmission level, just looking at the distribution lines, there's too much solar a lot of the time. And but you bring up the point which we are sort of trying to wrap our heads around now. At least I am from the project side. I'm sure it's pretty clear cut once I dig into the details. But although there is a great deal of solar. Or too much solar on the physical electrical circuit, that might not matter, right? It might be that to only call this green hydrogen, we have to have an accounting sheet of paper that is whether it's a PPA or the credits that are then tying it in an accounting sense back to a production.
Okay, so for the ITC, my understanding, at least the way it's being interpreted, is it is more of a physical thing, where you really can't, you have the associated renewables for the storage and the charging for the renewable, and I mean they're both behind the same POI. Yeah. And so the renewables can't be producing less than what the charging energy, the charging for the storage. So, but if you take it off the grid, then all bets are off, and it doesn't seem to count.
Right. Yeah. Although again, these are in resources that are under curtailment orders frequently. And so we're also trying to see if there's a way to tie if there's a way to tie a curtailment event and then say, hey, this resource is going to now charge in order to prevent that curtailment. Whether that then could qualify under, and again, that's probably not a current rule. But you're talking specifically about the ITC and.
I'm wondering if the rules would be different here for that.
Right.
Okay. All right. Anyway, just curious. It seems like that's kind of an open issue then, huh?
Yeah. Yeah. It struck me as odd that you could be on a circuit that is, overflowing with solar, but you couldn't call it green unless you got a sheet of paper.
Or unless it's physically flowing that way.
Right.
From this. Okay. All right. Thanks.
All right, and I do not think we have any additional questions in the vocal queue at this time.
Great. I have been monitoring the chat. I believe the presenters have been doing a great job of clarifying any chat questions that have come through, but if you weren't able to get any questions in, and for some reason if we haven't answered that, please feel free at this time. We have reserved some final Q&A, but that's more towards the ISO process and any questions regarding next steps in that regard. So appreciate it. We'll keep it open the last few minutes here, a minute for any last comments or concerns as we're wrapping up. Thanks, Stephen, for the thorough and enlightening presentation, and to all the other presenters as well. All right. Well, I'll be monitoring. I'll check in before we officially conclude, but I'll go ahead and pull up the next steps slide so you know where to send comments to. So as most of you know, by now we have a commenting tool that we're asking for comments to be submitted. A couple weeks after today is the norm on August 10th. And you can go ahead and log in, make a username in the tool if you aren't registered already. And a lot of great conversation today, a lot of good points to take back, hitting on the market design as well as different technology types and how they operate. So new territory for us, a lot of great ideas and sort of writing the book, folks. So thanks for being a part of this working group. We're going to look forward to your comments and integrate them for the next version, which is the straw proposal, as Gabe mentioned. And as a reminder, this was recorded. So you can look for that to be available in the next couple of business days. And just one last check, Adam, for questions.
We do not have any additional questions in the vocal queue at this time.
Great. Well, we have some time back, folks. Appreciate Stephen once more, and to all the other presenters. Have a great rest of your afternoon.
All right, ladies and gentlemen, this concludes our call. Thank you for using Event Services, and you may now disconnect.